the Arduino Day is conducted worldwide as a birthday of Arduino. So Arduino, as you know, is basically a open source platform which is used by engineers, hobbies, and then students worldwide to do number of experiments, to learn, and there are many institutes who teach Arduino as well. So Arduino, as a token of this appreciation all around the world. So what they are doing is they are conducting a birthday where all the communities, hobbies, and then engineers come together, form a group, and then they'll be conducting this Arduino Day. So as a part of this Arduino Day, what happens is people do present several things. Experts come onto the panel, give their views on Arduino, and then several points regarding the Arduino on how the platform shall be used, how the Arduino got evolved, what is the role of microcontrollers. There are several things. See, embedded is a huge platform, right? So there are several things to learn in this stream, embedded stream. This is just a small drop, actually. Arduino is a small drop. So as a part of this, we all when we say sponsors, basically AB Techville, and then Ustream, Talentive, and Skill My Subject, and our YouTube channel Way to Know. So we all came together, and we are conducting this event this year. So thanks for all the sponsors. So we will talk about the sponsors in detail at the end and when they present. So just to kickstart, we have several speakers here today, and then also several goodies to be won. There is also a quiz that will be running at the end where you can win goodies in that quiz. So please stay glued, and please provide your feedback as and when you feel. So that it will help us to improve and conduct better events in future. So with this basic introduction, I will pass on to Sanjeev. So Sanjeev is one of the speakers today, who is also the author of book of Arduino. So he wrote a book. So let us take his speech and then see what we can learn. So there are several things we can learn from Sanjeev. He's almost 20 years of experience. He'll be giving a lot of insights to us. So I just received one more hands up from Sinthu Kumaran. Yeah. Palani Swami, you can talk. You can unmute and talk.
No. I'm not raised any hands up.
Okay, no problem. No problem. I see your hand being raised. It's okay. Okay, so Sanjeev, the floor is yours. Please go ahead.
Okay, thank you, Dharani. Thank you for the quick introduction and also an introduction about me myself. And so welcome all. Can you hear me? So Dharani, I'm audible?
Yes, you are audible, Sanjeev. Please go ahead.
Okay. So let me share my screen and we'll start from there. Okay, so okay. Can you see my screen?
Yes, Sanjeev, we are able to see your screen. Just we will give some 10 to 20 seconds so that it populates for all, because everyone cannot talk. So even Sanjeev, I suggest while switching between the slides, just give a pause of 5 seconds so that the slide appears for the others.
Sure.
Okay, I think everyone should be able to see it. You can continue, Sanjeev.
Okay, welcome all. It's a pleasure to see the like-minded people gathered together today on the birthday of Arduino. So welcome all to Arduino Day 2021. Thanks to the event organizers, as Dharani mentioned. So I think somebody will be speaking about them as well. So hope through this session, right, we will learn from each other and hopefully will take away some lesson at the end of the day, right, for all of us. Okay, so okay, just maybe we can start with the latest happenings. You might already be aware about Perseverance, right? So this is the device. It's a robot. It's a kind of a rover which is now turning on the Mars, on the surface of Mars. And we all know what all it's doing. It's capturing sounds, it's capturing pictures, it's trying to find some ancient life, possibility of finding ancient life on Mars, and also doing several scientific experiments on a very distant planet, right? So it is able to do all of those stuffs because of a brain which is kind of designed into this rover, and that's a computer, right? So it has a processor, it has certain memories, and it's pretty much alike to what we are going to see in Arduino. So it's only a little bigger version of it, but as you see that it doesn't have large amount of memory as well. In your desktop or laptop PC, you might have a larger memory. It's because of what is necessary they have done, because you cannot put so much into a small piece of hardware which you are sending to a so much distance planet, as well as other design constraints like it has to be radiation hardened and things like that. But this is also controlled by a computer, and what amazing things it is doing, right, on a distance planet. So this is a brief about the processor which is used. So if you are interested, you can read more about it. It's a PowerPC architecture, and it's from a company called Bay Systems. And you might know her already, like. So she is Sophie, the first robot who was awarded the citizenship of a country, right, Saudi Arabia. And this is also, as you know, that electronics is inside her, which is kind of and along with the artificial intelligence, the other programs, the control algorithms together, she has been created. So these are little bit, some inspiration, like where we want to go or what we want to do. So why learning Arduino, right? What are the reasons we should be learning Arduino? So I think that first of all, we have digital creativity in each of one of us. We want that to come out. We want to demonstrate that. Obviously, learning coding and see a hardware piece of something coming alive. It could be some equipment or some device which you create for your house, automation and stuff like that. You can build productive gadgets for home, community, business, and showcase. Might be a good business idea as well. Also hands-on experience, and maybe you can use that knowledge for far richer than what you might be doing currently. Maybe you'll be doing something like Perseverance later. Actively contribute to online community and get noticed. So if you want to be engaged with the online community, which is a vast one, also take part in making, right? So these are the learning objectives that I think of, and maybe I think that we might be all aligned to at least one or couple or more of those. That's why we gathered together. Now, why Arduino? Why specifically Arduino? Because this is a great stuff to start with, to begin with, right? The strong hardware ecosystem is the first point I would like to point out here, because the Arduino boards that ranges from a very basic one to a very complex one. We have the hardware shields easily available. The software is great. You can pick up very easily. As a starter, even if you don't know coding, you need not know C, C++, but still you will be able to code. That's what I'm going to demonstrate in this presentation. Also, there are very, it's a strong online community, as I mentioned, right? They are constantly working and putting codes into the GitHub and, stuff like that. There are other vendors which are supporting with free online tools. A couple of those we are going to talk about during the session, or, latter part of this session. And also, things are very easy to build. You don't have to do a great lot of soldering. You have shield boards, you just plug it in or use a small breadboard and wire it up and start, your application. Now, Arduino IDE, that's a software. Now, someone might think that, what all hardware it can support, or is it only the Arduino boards that can support? No, it supports a great variety of other hardwares as well. So as you could see on the right side, top one, you have around 40 Arduino boards, 40 plus boards, which the software supports. Then you have the teensy boards. If you're familiar with some of the Freescale tiny boards, these are also open source hardware with which you can develop a great deal of applications. Then from AI, there are several, ESP 8266. If you are familiar with Node MCU, those boards are also supported by the software. The microbit from BBC is also supported by Arduino IDE. And as you might know that in 2021, this Raspberry Pi organization, they came out with a nice microcontroller. So far, they were more focusing on the processors, the bigger boards, the more powerful boards, but they came out with this RP2040, which is a dual core microcontroller, and it's a very nice one again to start with, right? So this might compete with Arduino boards, but at the beginning itself, Arduino mentioned that they're going to support this hardware also with the Arduino IDE. So that will be very nice to see that another Arduino board coming out might be coming very soon with this nice microcontroller. Already there is another board available from Raspberry Pi organization with this microcontroller on it, but we'll get a similar board from Arduino as well. Okay, so this is a family. This is a family of boards, Arduino family of boards. Now, just I'll give a quick pause here. It's a short pause just for you to understand. There are 3 levels I have mentioned on this slide. So the topmost one are the simplest one to begin with, right? I have not shown all of those because I can't show all of these in a slide. You can go to the Arduino website and you can see which all boards are for the entry level, right? So Arduino UNO, so that's the first board. UNO means 1 in Italian, and then you have the Arduino Nano, Micro. UNO was the first board, and later on they came out with the different other boards. So those 3 are the entry level you can start with if you are a beginner. Then if you need more IOs, more memories, then go to the next level and Arduino DU, Maker 0. So these are the certain boards. Arduino Mega is another board, but they are going to obsolete that board. So you might not get it, but DU is a nice one with more GPIO and more memory, right? Then the enhanced feature boards. So those are the boards which has more functionalities into, more memory, more communications like wireless communications, Bluetooth, Wi-Fi, LoRa, whatever you want. So those are used mostly for the IoT and machine learning applications. We have some subsequent presentations regarding IoT applications and more about the the open source hardware, other open source hardware platforms maybe. Okay, So this is the latest board into the Arduino portfolio, and now they're focusing more on the industrial platform as well. And this is called Potenta H7. It has a dual core microprocessor, very strong. It's a much more, powerful than the other ones. And the two processors can run tasks in parallel. You can program one core using maybe Arduino language. Other core can run even um, the MicroPython. Okay, so it's capable of running the real-time machine learning algorithms. It's called TensorFlow Lite, which it can support. It's also compatible to Arduino IoT Cloud. So this is something I saw recently. Arduino has come out with a IoT Cloud service as well. These are the spectrum of microcontrollers the Arduino boards cover. So this is what I'm talking about are only the Arduino boards, and it covers three different manufacturers, mostly the microchip, the Atmel microcontrollers. If you are familiar with that, those Atmel microcontrollers were procured or basically acquired by Microchip, and they are now owning these microcontrollers. So but still that Atmel branding is used, and that's why you see 80 at the beginning, right? Atmega 328, that's on the UNO. Then Atmega 32 U4, that's used in Leonardo. So if you there are several other boards in which the other microcontrollers are used. And there are some powerful microcontrollers or microprocessors, one from the Nordic Semiconductor and the other from the ST microcontroller, which are used in the other Arduino boards as well. As I mentioned to you just in the previous slide, Potenta uses the STM32H747, right? That's the dual core microprocessor, and you can have a wide range of memory. It's a flash ranging from 8 to 128 megabyte, and RAM ranging from 8 to 64 megabyte. That's a huge memory, right? And clock speed also, if you see, it's around 480 megahertz, and that so it can run several different complex applications such as cloud and IoT based kind of application. Okay, now what we would need to start our Arduino journey, a small lab. You can be in your home. If you love to set it up, then I would recommend you have at least one Arduino board, and to start with, you can start with Arduino UNO. You need to have breadboard, at least to have some kind of wirings done. Similarly, the breadboard wires, couple of LEDs and resistors and displays and stuff like that. If you want to go more advanced, you can purchase some of the the Arduino shields. There are several companies who supply low-cost Arduino shields and easily available on Amazon or various other platforms. Then the Arduino IDE, which is a free software from Arduino. Then a power supply. So this will be, even your USB cable could supply the UNO board. You did not use a power adapter. So the very basic things is you need an Arduino board and a cable to start with, and you can expand on the all other equipments if you need, if you want to make it a more advanced kind of lab. Okay. So we'll go to the Arduino hardware next, and maybe I missed before, like you might already have some questions, but due to the interest of time, we'll take the Q&A at the end of the session. Okay, so the Arduino UNO hardware. So just to start with, right, we need to know what all it has. So Arduino UNO hardware, it has a, as you could see, it has different components inside it. Some maybe if you are already not aware, there are two microcontrollers on it. One is doing the USB communication here, sitting here, and the other one is for you to program, right? So you can load your program in this microcontroller, which is the main Atmega, 328B microcontroller, and your program goes there. So inside the microcontroller, you have the memory, flash memory, and program sits there. It runs on the RAM inside, and you have the various I/O ports, and these are the power jacks. You have LEDs and stuff like that, and you have a reset push button also. It has analog input. So this particular section is for the analog input. There is an ADC inside the microcontroller, but these analog channels are maxed so that you can use at least 6 different analog inputs connected to Arduino. You can have several digital outputs, digital inputs and outputs. You have one UART communication port like this TX and RX. This is the UART communication port. You have I2C communication port. Right here you have two I2C lines. Then you have the other. So all these ports can be configured as normal digital input output as well. The ports which are marked with tilde, these ports can also be configured as pulse width modulated output ports. So you can generate some pulse width modulation output, which can be used to drive motors to control the speed of the motors, or even you can generate some sound using buzzers, etc. So we'll come to those later. Now, if you want to see from where you can get the information about the boards, you need to go to the Arduino website. And for example, I have opened this page where it shows the Arduino UNO hardware, and then you can see the pinouts. You can have you know what pin, and each pin has multiple functionalities, as you could see here. So these are your power pins, and you have the analog pins. The analog pins also can be configured as digital pins. And then it shows also the what LEDs are, other kind of pins which are there. So this will give you the idea about the pin diagram. Recently, Arduino has come out with a nice interactive schematic PCB and your 3D model of the board as well. So if you are interested to know this component where it's there in the schematic, you just click on this here. It shows, okay, this component is a capacitor, and location is on the top side. The part number also it gives the values, everything. And you can click on schematic and it will show where in schematic it is there, right? Very nice. So it shows, okay, it's there on the output of the regulator and used as maybe a filter for this 5-volt. It also shows where on the board layout it is there. If you are familiar with PCB layout and interested to know, you can also view that. But it's not necessary for you to know all this stuff to start with, right? So that's what I'm going to talk about more in this presentation. That without knowing all these things, also you can start. But in case you are interested, and some of you might be interested in knowing the hardware as well in detail, you can browse through the Arduino website. For each of the boards, they have given this level of information. So you have an overview section, you have the tech specs, documentation, and some questions, right? So very nice, very nicely organized the website. This is also I like very much about Arduino, and which I maybe did not mention in my earlier slide, but this is also a very, very positive point. Okay. Coming back to my presentation, so we'll just move to the next slide. So how to power up Arduino board, right? So it's very easy. You can either use the USB cable or use a power adapter. But when you are downloading your cable, downloading your program to the Arduino hardware, you need this USB cable anyway. So only the USB cable is sufficient for you to power up and also program. But once your program is proven, and you want to deploy your product in the field, that time you might not need the USB cable, and that time you use a simple adapter and your program will keep on running, right? Okay, so this we just talked about briefly. So first you need to know the pinout diagram for each of the boards. So whatever board you are going to use, you need to know the pinout and the functionality of those pins. You can read about those. You can understand what you need and what kind of pins you would need to use. This is also, we talked about the layout, but yeah, you don't have to browse through the layout files, but you can now use the online viewing tool what Arduino has provided. And in case you are interested, you can also browse through the datasheet of those components which are used on the board. So this is what we just talked about earlier. We might think that, okay, Arduino Uno, I'm just programming my stuff in the board. So I have the one microcontroller, but actually there are two microcontrollers. One is taking care of the USB communication and loading, uploading your program into the main microcontroller. Okay, now just a brief about microcontroller. My colleagues, will be talking. There is a particular session on the microcontroller where my colleague will be covering it in detail, but I just wanted to capture a few important points. So when you look at a microcontroller, right? So these are the important aspects you need to take a look at. So what is the data bus width? So usually we talk about 8-bit microcontroller, or 16-bit or 32-bit. So as we talk about our PC processor, right? So 64-bit processor. So what is the minimum width of data it can process, right? Flash memory. So how much memory? So flash memory used for storing our program. So how much memory you have to store your program. So larger the memory, larger could be your program. RAM is a rough memory where it's kind of a rough sheet, right, where you do the calculations and process data, right? Here, more the size of the RAM, your execution will be much faster. The program execution will be much faster. Then you might have some E2 memory where you can store some data which you don't have to access very often. For example, ID, or some stuff which are maybe during the power up you need to access, or very less often you need to access. ADCs. So if you have ADC inside the microcontroller, you can read the analog data. Otherwise, you can't. Timer and counter. Obviously, you need to use the timers and counters for maybe counting the pulses, maybe for speed measurement, or maybe for adding some delay, adding some, maybe you want to implement some delay in your program, you need the timers. And there are various other applications for timers and counters. Communications, you might already know about SPI, serial peripheral interface, I2C kind of communications. Also, you have the wireless communications like Bluetooth, low energy, BLE, BLE 5.0, etc. Wi-Fi, LoRa, LoRaWAN, if you are aware about, and there are several other communication protocols which the Arduino boards cover. Some of the Arduino board supports different communication protocols. Obviously, then last but not the least are the GPIOs. So GPIOs are used to read the inputs and drive your output, right? So more number of IO devices you need to control or to monitor, that many GPIOs you might require. Okay, so these are just some of the basic stuffs to know about a microcontroller, and just for your knowledge. Yeah. Okay, functions of a microcontroller. So it's just a device which it can be called as a brain of the board, and it reads inputs and drives outputs, and obviously it drives the outputs and as per the program which is uploaded into the microcontroller, and this program is user defined. So the inputs could be again, either digital input, analog input. The outputs could be digital, pulse width modulated output, or DAC output. So and DAC means digital to analog converter. And so you have some digital data and convert that into some analog voltage. Maybe in this case, some voltage between 0 to 5 volt, right? And then you have serial communication interfaces like UART, SPI, I2C, USB, Ethernet, and the wireless protocols I just talked about previously. These are the examples of some digital input devices like push buttons, touch sensors. Potentiometer might not be a digital device. Here I have shown maybe, okay, this is a kind of a position switch. Yes, this could be a digital interface. Digital output devices are again relays and the 7-segment displays, maybe DC motor where you are just turning on and turning off the motor, and the distance sensors, ultrasound distance sensors, and stuff like that. Analog input devices, as you know, maybe the light sensors, LDR, and some other light sensors. One light sensor we're going to talk about, and I'm going to demo, is the VML 7700. I'm going to connect this light sensor to one Arduino board, and I'll show you how to, how quickly we can build a program to capture the data about the ambient light. Sound sensors, again, the microphones, the analog microphones. The analog output devices again could be various motors where you will use the pulse width modulated waveforms or the signals, and some digital digital to analog converters might be present in your microcontroller. If it is not there, you can use the PWM, and you can also drive the buzzers. So buzzers are also like it will generate the sound, or if you have some speaker drivers, you can use that as well, and you can generate sound using some of the Arduino boards. Next part is to build your circuit, and again I will demo towards the end of the session how you can quickly simulate the circuit in a tool called TinkerCAD. So yes, but building a circuit is very easy, to start with. So I'm going to demo that later during this session. So so far we talked about the hardware. Then what about the program, right? Programming software. So Arduino has a very nice programming software, and that's called Arduino IDE. IDE stands for Integrated Development Environment. The latest version, which was there till yesterday, was 1.8.13. You can find the software here in Arduino website, and you can install it. You have different all the different ways are supported. The IDE includes all the basic elements for you to start programming. So it has a programming editor. You can write your code here. It has a compiler which will compile your code and find the bugs or syntax error and stuff like that. It has a beautifully integrated library support. That's what I'm going to demonstrate, that you don't have to write your own code basically for most of the stuff, and you can use the library to a great extent. Then the serial port driver for uploading the sketch into the hardware, tools such as serial monitors, serial plotters, very useful for debugging and also for capturing the data. So all those tools are integrated into the IDE. So once you install IDE, you can use all of those, and you might not need anything else. So it's very simple GUI, very few menus. It's won't confuse us with a lot of menus and stuff like that. Very simple menus, and you can just scroll through those, and you can get familiar with these maybe in a day, very fast. So most of the the critical ones I have just shown here. So in file you'll find a menu called examples. So that should be your starting point. And in Sketch menu, you can find the verify and compile menu, which is also available here. And for again, in the Sketch menu, you can get upload, so you can upload. So again, there is a shortcut here. Now, what is Sketch, right? So in Arduino language, a program is called Sketch because the way Arduino IDE was designed, that it should not attract only the programmers or the digital engineers or the electronics guys, but it should even attract the people from arts, right? Art background. So that's why it's more of artistic approach for this tool, and that's why it is called Sketch. The programming language is not actually C++, but it's based on C++ and based on the C++ framework and some of the libraries. And the syntax is heavily used from C and C++. But it's not exactly, it's actually a C++ code. And the Arduino Sketch has the extension .ino. So this is the last part of Arduino INO. This is how it is there. The language is designed to be extremely simple and for the beginner to pick up and to start with. Some basic differences from the C++ language. For example, Sketch is written in two functions, setup and loop. Usually C code or C++ code, if you are familiar with, has one main function, and inside that you can call different functions. But for Arduino, you have setup and loop, two different functions. Setup is to set up your hardware and to set up your IO to configure that, and which runs once. And the loop is your program actual application, and which keeps on running repeatedly till you power it off or interrupt the hardware. Okay, the language is designed to be extremely simple for the beginner to pick up, as I mentioned, right? So that's very important for us to know, so that we should not have any fear in our minds that, okay, I'm not a coder, how can I start, right? It's very easy to start. I'll show that to you. Okay, then I have captured some of the basic components of the language, but I'm not going to cover in detail. You can get all this information in the Arduino website itself. So they kind of have segregated this language into three basic blocks. So functions, where there are built-in functions for you to control the hardware. And then variable and constants, so Arduino data types and constants, and the structure. So here it's more of a the setup and loop, what we talked about, and what all it basically here it takes most of the functionalities from C and C++. So just to start it with structure, and it has all these different components. You can refer those in the from the website. It has the similar Boolean operators, bitwise operators, comparison operators, arithmetic operators from taken from C++. Very easy to refer. You can refer each of those functions, whatever you need, and you can refer to the website and find out, read about it, and use that in your program. Then the variables, so there are some built-in constants like high, low, input, output. So these are just to provide simplicity for a hardware engineer to write a code, or to a guy who is familiar with embedded hardware. The data types are again similar to C, C++, as you can find, and there are many more. There are some conversions. You can convert maybe int to byte using this. Then there are several other conversions. Then variable scope and qualifiers and utilities. So again, you can go to the Arduino website reference, and you can learn about the language. But it will be very easy. Maybe for a day, it will take a day for you to to pick up. You need not learn everything on the first day. You start programming, and in the process you keep on learning, right? Some of the functions I have just highlighted here, like for example, if you want to use some digital IOs, you would need at least these 3 functions. So the pin mode, it configures your pin as an input or output, or even whether you need a pull up on the input. Digital read, as you know, it reads any digital input. Digital write drives GPIO either high or low. Similarly, you have the analog IO functions, the advanced IO functions. If you want to use a buzzer, use a tone function to generate a tone. Then no tone. So if you want to start the tone or stop the tone, right? Then shift in, shift out if you are using a display. So these are some of the functions made so easy to understand. You can even Arduino has documented, Arduino website has documented each of these functions in detail, so that you need not worry about, okay, how do I learn about these functions. There are several more functions like communication. So we are going to use a serial function in the code demonstration, what I'm going to show to you later. And using this, you can communicate to your PC on the serial port, USB port. You can use the serial monitor and serial plotter, and you can print the data on your serial console, and you can see. Very easy to use that. You need not know a great deal of C or C++ because of in order to use Arduino. Again, for time, if you want to add a delay in your code, just add delay and maybe 1000. So 1000 will give you 1 second of delay. So all these functions, again, you can read about from the Arduino website. Okay, so that's all I wanted to cover in the presentation and latter part of the day, right? So maybe towards the end of this session, once we have all the theoretical sessions covered, I'm going to show the how you can make circuits and also simulate, and you can write some code, or you can copy a code from the library and just use that for simulating. Even without having the real hardware, you can do a great deal of learning from this particular tool, which is called TinkerCAD. There are similar tools available like Proteus, but I have highlighted this tool because it has the Arduino board also in its library and supports the Arduino IDE software, like the Arduino programming language. So I'm going to demo that maybe towards the end of the session. Also, we have, as I mentioned to you, there is an ambient light sensor called VML7700. I'm going to show that to you on a real hardware. That hardware is here with me. I will connect that to the PC. I might not be able to show the hardware to you, but I will capture the data and show that to you on the screen. We'll capture the data and see that on the serial monitor and serial plotter as well. And then also I will show how you can capture the data on an Excel spreadsheet. Right? So this will be part of the demo session coming towards the latter part of the today's session. Okay, so with that, I think I have covered what I wanted to cover in this session. And just to mention to you, as Dharani has mentioned, I recently wrote this book, Begin with Arduino. And whatever I have covered in my presentation are basically covered in this book in great detail, like how you can start with Arduino. If you are interested, it's available on Amazon or Flipkart. You can have either the Kindle version or the printed version. Okay, so that's all. So thank you very much. Now maybe we can open for the Q&A if we are okay with the time. So pass it over to Dharani.
Yeah, thank you, Sandeep. So guys, if you have any questions, you can just raise your hands so that we can just take the questions. So Sanjeev just to give you a background, I think I've already given it. He has around 20 plus years of industrial experience. So he has worked with various companies, and as he said, he also wrote that begin with Arduino book in a very simplistic way. So even a school level guy will be able to understand that language. And if you see the book, it just starts with the introduction of what is Arduino, and then what are the different. It doesn't just talk about Arduino, it also gives a view of what the comparison with the different boards that are existing in the market, like the microbit or Raspberry Pi, and then there is comparison of features, and also different. It takes a different approach from the other authors, where generally the others start with Arduino and then talk about IDE and all, but Sanjeev takes a different route, where he initially explains what are all the components that are required to build a home lab. So as he mentioned in one of the slide, if you have followed, he talked about the home lab, right? So all the components which are required are mentioned in that book. I think it's very useful for the guys who especially for the beginners who wanted to jump to Arduino, or even the experienced guys can just have it to refresh the things that they have in mind. So please do suggest, and if you have any questions, please raise your hand. We will take the questions. Otherwise, we'll move to the next presenter. Okay, so if there are no questions, I think Sanjeev will move to the next speaker. So then,
Yeah. Thank you. Yeah.
thank you, Sanjeev.
Yeah,
Yeah.
in the course of the session, also, if you have any questions in your mind, right, you can write it in the comment section, and we can answer those questions later also.
Yeah, Sanjeev is a very experienced guy, participants. So you can reach out to him. We have created a WhatsApp group as well, so we'll add them. So any question, any technical query related to electronics, you can just reach out to him. He's very approachable guy. And now moving to the next speaker. So the next speaker would be from AB Techville, one of the startup from Hyderabad, where their major business is into IoT kind of platforms, and they also mentored around 3,000 plus people across India on IoT and other platforms. And it's good to have them in the event today. They are also the co-sponsors. So we have Akshay and then Bharadwaj Arvapalli, who will be talking about another different topics in Arduino. So let us listen from them and see what we can learn. So over to you, Bharadwaj and Akshay.
Yeah. Yeah, thank you, Dharani, for the great introduction. So I'll just share my slides. 1 second. Yeah, I hope you can see my screen. As Dharani sir said, I am Akshay. I am from AB Techville, and right now Arduino is a basic development board where we use to build different and creative projects, right? So where does that Arduino actually implements in the real-time scenarios, in the real world? What do we use, and how do we use Arduino is the main thing people should know. The thing is, just first we go to Internet of Things, and then we will know we can go to Arduino, where how we use Arduino in Internet of Things. That is our main focus for today's topic, and I hope everyone knows what Internet of Things is, right? So we'll discuss the same later. But does anyone know how does it all started? Right, most of the people who I met doesn't know them, so I'll just start with a small story where our IoT has started in the beginning. So if we see the graph right now, global connectivity near 1900s is 0%, like there is no connectivity at all. Because of there is no connectivity, there is no information flow, or there has been very little information flow between continents or between countries. They use pigeons or ravens for transferring the messages, right? After that, at certain point of view in 1900s, there is a telephone. Around 1900s, there is a telephone got started. From there, it has connected from city to city, country to country, and continent to continent even. Right now, all the information is developed till that every each and every person has a own mobile phone where they can just connect to other people, and they can just talk to them whenever they want in seconds. So all this is like human to human transfer of data, talking and all that, right? So after that, right now, if you see, there is an inflection point in the between. In that inflection point, the data transfer has begun between machines and machines, where machines talk to machines, machines sends the data to machines, like sending a text message or WhatsApp message, or sending a sensor data. Though, so those all started around 1975. That is where inflation point also started. Before 1975, there are like very limited or 1 billion, if you see the graph, 1 billion, less than 1 billion points are connected for information sharing. After that, that inflation point made all the difference. That made things much faster, much quicker, and it has made each and everything to that can be made smarter and talk to each and everything. So that is where Internet of Things come in the focus, where thing can start talking to another thing using different technologies and all. So this is all good, but how does it started? Like who started this data transfer between machines and machines, or every what kind of product or a machine, like that. If we go to 1982 at Carnegie Mellon University, there are four people who are very lazy. So am I. So these lazy people, what they did is they used to go to Coke vending machine, and the Coke vending machine used to show empty Cokes. There are no Cokes, or they used to be like not normal temperature Cokes. There are no cold Cokes. So these kind of things used to happen in their universities. So what they did was they connected their vending machine to their desktop or Macintosh computer, which then was available. So what they did was they get the data from vending machine that if the Cokes are available or not, and the Coke is cold or not. So they connected a sensor, temperature sensor inside the Coke machine, and they connected that to their desktop. So they used to sit on their desks, and they used to check if the Coke vending machine has their required positions or not. Then if there is no positions, then there is no need to go to the vending machine which was far away in the second block or something like that, and they used to just go to some other place. So their laziness started this thing. So what they did here, even without awareness, they created a machine to machine communication, where Coke vending machine started talking to their personal computer and telling that what are the items are available inside that machine. So this is one side of communication where machine gets to sends the data to computer where human looks at it, right? Human asks the information. What is the second step of this process is this one. Yeah, in 1989, same thing. John Romkey, what he did was when he done with the office work or when he done with this done with the process, he used to go to home and he used to cook the food or toast the bread. So if you see, there is a bread toaster in the picture, right? So he used to toast the bread, and meanwhile he was like very hungry, and he used to stress out a lot. So what he did was like he connected SNMP protocol to his toaster and to his desktop at his office, or even he used a mobile phone SMP, a single switch which can switch on the toaster. So before he reaches the home, he used to just switch on the toaster using that particular switch, and like he knows the timings, right, where he can when he can go to his home before 15 minutes. If he switch on the toaster, that would be enough for him. So he used to take control of that toaster using a switch which is not nearby to the machine. So here he also created where he gives order to the machine. So in the previous scenario you are seeing Coke machine sends the data, and a person receives the data, right? Here a person sends the data, and a machine receives the data and does the work. So that is where that is these two scenarios get together, combine the IoT. Is that correct? Am I clear that this is the where IoT things work? Does anyone feel that IoT like this is the better good example for the IoT? Yeah,
Uh, Akshay, it made the
yeah,
point, Akshay.
yeah. So moving on. So sending data to human, on or off by human. So sending data to human, receiving data from human. This is where Internet of Things, right? So I will go one step further to prove that there is more smartness to the IoT. So connecting devices is what IoT does, right? So first I set up an alarm in the morning. So when I wake up, I want to go to bath, right? Generally, people goes to bath. So I want my geyser to be switched on and ready for me to take bath, right? So when I switch on my alarm connects to my geyser, where geyser switches on before I wake up. Like if my geyser takes 5 minutes or 10 minutes to heat it up and be ready, my alarm will connect to geyser and tell that it's 10 minutes to wake up. So switch on yourself, and it will heat up the water. Then that heater, after using that heater will know that it has been used. Then it will connect to my toaster or microwave oven, whichever it is, and it will tell that make the breakfast ready, so that after completing the bath he will take a breakfast. So even after that, my toaster knows or microwave oven knows that I have done my breakfast. Then microwave oven talks to a garage, and garage will open, so that I'll take my car and or my bike or any smart gate, right? This is basic scenario where we get up and bath, take breakfast, and go out. So this is where connecting things from alarm to my geyser and to my breakfast maker and to my gate, they talk themselves. I don't tell them to tell the other thing to start off. I'll just program it before that. before going off alarm, you should open start heating the water. Before completing the heating of water, you start toasting. After toasting, switch on the gate. Open the gate. So this is the smartness where we have IoT right now. So you think this is the IoT's better example? I hope you do. And we go one step further even. Okay. And this is where future goes. Like I set my alarm at 8 o'clock, but I have a meeting in somewhere, let's say high tech city. My Google Maps will be synced to my alarm, telling that today there is a more vehicles or more traffic today. So if he wakes up at 8 o'clock, he might not be reaching by 9 o'clock. So wake him up at 7:30 itself. So my alarm will wake me up at 7:30. Before that, it will automatically update all the details to the central processor, where it everything will be switched on according to the 7:30 timings. So the calendar will be synced to my alarm. Google Maps will be synced to my alarm. My meetings will be known to my alarm, and alarm will take care of everything. So this is where future smartness of IoT is going to be happening. So are you satisfied with the example that IoT is going to be way smarter in the future? Yes. So this is where IoT is going to be in future. After the IoT is basically collecting data from the sensors, right? So in future, after the next step of the IoT is analyzing the data. So this is where IoT is expanding to be fitted into the newer technologies and newer environments. So if you see, these are the different types of scenarios where we can use IoT. First one is smart homes. Smart homes, automating your smart homes. If you enter the room, in a second, it will switch on the fan and switch on the lighting. Depending on your mood or timing of the mode, it will automatically learn how your general schedule of the day was, and it will automatically change the lighting according to your mode. Or you can just control your lightings and everything using your mobile phone or voice commands, all those things. And secondly, you have smart health. Smart health is like monitoring your health. Like everyone knows smart bands and Fitbits, right? It will monitor your steps and calculate your heartbeat and updates your health reports every day. So even further, we can track your brain waves and check that how much stressed you are and what are the relaxation stress reliefs you have to take care of, and it will be all will be recorded and analyzed, and it will give you the feedback of how you should relax or do stress relief activities. All those things in smart health. So next we are coming to smart environment. Obviously, we have solar panels, wind energies, all the renewable energy sources which can be connected using IoT or comes under smart environments. And obviously next smart agriculture, like what we can say, we have in drone agriculture in these days, where you can just send a drone and spray all the pesticides, and you can just what you say connect the water flow of your environment, agricultural environment, and spray it. And there is a very keen and very nice POC which we got, is like creating a home agriculture, right? Home farming, where in penthouses most of the people are planting their own plants, and they want to monitor it 24/7. They want to know how the health is growing and all. So we can just implant some small soil moisture sensors, and we can switch on connect smart motors to water flow, where it can just switch on the motor flow when the hydration has been reduced, or even we can control those motors and sensors where all the implementations are happening. That is where smart agriculture is taking the next few steps of in the IoT. And you know about smart cities, we have smart lightings and street lights, everything smart connect, like GPS like tracking your vehicle and connecting. What we say, even GPay is one of the IoT product. Like you can just transfer your money from bank account to another bank account using QR code and a scanner, right? And one very good use case from smart cities is like uh, bin collectors. Those guys are like when a dustbin in your area, like GHMC dustbin will be there in every area, right? When it has been almost filled for a day, it will send that this bin is going to fill today, and it will send the data to GHMC people. And in the same way, all the GHMC bins in the city will send the same data to GHMC people. Then the GHMC will get a smart route where they can just go in the very what we say, very less distance, in which way if they go, that will make them the less travel. In that way they can go and they can collect all the bins from and refill the bins, right? So first we are taking sensor data and sending to GHMC and analyzing the data and creating a route. So that is what the flow is here. And smart retail, yeah. So there was a very uh, very automated retail store in America where Amazon has deployed, where you just have to go inside and grab an item and you can go outside. It will automatically detect whatever items you have picked, the same cost will be deducted from your account. So what it does is like you will have a customer ID. It will scan your customer ID while using face recognition or even a card in your pocket. And the every item has been registered with an RFID tag. When you grab all the items and going out, right, it will scan all the RFID tags and it will just connect to your account and it will debit automatically. There is no line, there is no paying of money on and standing in a queues or retail counters. That is where smart retail is happening right now. And even in smart retail, there is one more use case where you can just go to a mirror and you can select your top or you can select your pants, where it will automatically show how those pants looks on you or how those tops looks on you, where you can just scan the tops and you can order from that particular mirror. That is where smart mirrors, smart retailing is like a vast technology again, vast area again. So smart grids is like connecting all the grids in the city, right? Where power points or what I mean grids is like all the collecting all the electricity from the city, where there are different kinds of generations, like in nuclear power plants or in where are solar farms and wind energies. All those can be connected to one single line, where it can automatically uh, credit you if you have a created a solar farm, let's say. It will automatically calculate all your energy which has been sent to a single grid, and that client will credit you which amount, depending on how much energy you have provided to him. That client will provide all the energy to the entire city. So this is kind of a smart grid kind of industry where IoT is going to be used for connecting the sensors in each and every grid and all. And again comes to smart industry, is like every industry right now is totally automated. Like if you want to create a phone, the robots will just switch everything, like pack everything on a PCB, and they will just enclose it with a plastic box. So everything is automated, everything is robotics, and industry 4.0 section is going with the same thing, where IoT is can control a machine, where that robot can do the singular process with within less period of time, so that the production levels goes high and it gets a higher income. So that is where smart industry in IoT comes under. So all the robotic operations and all those are pre-programmed. So these are the limited scenarios where we have searched for them and put it here. But there are many other scenarios where you can use IoT and all. So you can search them. If you have any doubts, you can contact us. Yeah. So next, coming to IoT, I have talked about IoT, like what it does and how it works and all. But how the core technology of IoT works, that is where we know what IoT is, right? So this is a basic IoT technology architecture. First, devices. Any device that is connected to a network is called a data device, where it sends data to any cloud and all. So first, it might be a smart car or a GPS from a truck, or even a temperature sensor or your mobile phone. Everything is a smart device, right, nowadays. So that device is one end of a IoT. That device is connected to a network, which is like Wi-Fi. Either can be Wi-Fi or 5G data, or a router or a server, using these REST APIs, MQTT protocols, HTTPS protocols, all those things, right? Those are connected to one cloud service server. That cloud server has again more in-depth visualizations and technologies. Uh, Basically, the connecting the device data to network and sending it to cloud, and after that data visualization and pulling that data to a storage. So these three things, your electronics embedded systems, or what we call as sensors and processors, are connected to cloud. Those sensors and processors and cloud all combined is called a IoT technology, where sensors gives data to processor, processor process the data and sends them to cloud servers. These three are combined is an IoT technology. So first, coming to the sensors, we have different kinds of sensor: visual sensor, electromagnetic sensor, motion sensor, chemical sensors, and all these kind of sensors, right? So in different kinds of sensor, I'll go with the basic kind of sensor, which is a button. Button is also a kind of sensor, where if you clicks the button, it will sense that okay, you have given an input. So right now, in mobile there are 8 to 10 different kinds of sensors, like camera, IR sensor, and proximity sensor, touch sensor, microphone. All these are sensors of a mobile phone. And there are two kinds of sensors. One is input sensor and second one is output sensor. Input sensor is a sensor where it takes data from the human and sends it to the processor. And output sensor is something that takes data from the processor and sends it to, gives it out to the human. Mm, like I have different kinds of sensor here. Just, uh, so I have, 1 second. I'll just stop my presentation and you can see my video. So I have different kinds of sensor. This is an ultrasonic sensor, if you can see. So this is an ultrasonic sensor, where one module here will sends the ultrasonic sound waves, and second one receives it, and then you know how much, like what is the distance between a particular object from this particular position to that particular position. This usually uses behind the car, where while you are backing up, it will sense that there is a obstacle behind you, right? So this is the sensor where you use that. And I hope everyone can see my video. And this is a smell sensor, like smoke sensor kind of thing. any air particle which can be which is near around this can sense that quality and quantity of the air particle and sends that data to the processor. So, and we have one more sensor called RFID sensor. These are the RFID tags. Yeah, these are the RFID tags. If you just keep it here, if you see in metros or in even in smart cards where one touch cards are available for all the credit cards right now, right? So if you just keep that smart cards here, this is the sensor where they use. This is these are all the development sensors actually, so that you can see how they works and all, right? So all the production kinds of sensor are very small and very minimal sized, so that the compactness of the product will go very large, like compactness and the production levels of the product will be very less. So this is one of the sensor which is for soil moisture sensor. It just sends the electric signals from one place to another place, and it will just sense the how much humidity in the soil or humidity or water, if there are any water presented inside a soil or even directly in the water tanks. It can sense those things. And these are all the input sensors. And we have output sensors even. So this is kind of output sensor where you can see micro servo motor, where if you just give the input, it will just rotate whichever angle it has, 360 degrees angle. So in whichever angle you want, it will just rotate there and stop there. And this is a DC motor where you can just rotate all the things. So why I am showing all the sensor is like all the processors are connected to these sensors, and these sensors are the gateways to all the IoT technologies. Even if you are connected to with Arduino or Raspberry Pi Node MCU, so all these are connected to these particular sensors. So after this, we have Arduino and Node MCU, all the processors. So all the sensors combined and connected to the processor, right? So there are different kinds of development boards available for connecting all the sensors, where it you can connect any kind of open source device to Arduino. So the very good thing about Arduino is like you can connect any kind of open source device to Arduino, where you have more community support. If you want to develop anything, you will just have a very useful resources in every angle. So if you want to build an RFID scanner, there are always libraries available and updates available. And even there is a community members where in the form, if you just ask if you have any query that haven't solved it, the reply will be very fast. Anyone can who develops an Arduino can reply to that particular question, all those things, right? So that is where Arduino comes very fast in emerging technologies and developing a customized products which in IoT fields. So we have Arduino, Node MCU, BeagleBone, and Intel Edison. These are all the different kinds of development boards we have. And Arduino and Node MCU uses Arduino IDE, where you can code in C++ languages, as Sanjeev sir already told you. So in that way, you can use Arduino in much efficient way manner. So all this, the third part of obviously the IoT technology is cloud. All the sensors are connected to a processor, which is Arduino or some other development module, and those Arduinos and some development modules are connected to a network where the data can be uploaded to cloud. So these are the three main steps where IoT comes under, and Arduino is one of the base module where you have, if you want to develop an product which is smart enough to communicate from human to a machine and machine to a human, that is where Arduino plays a key role in connecting what we say sensors and cloud, which is basically connected to mobile application or human. Yeah, I think till now we have a theory part of how Arduino comes and like how IoT comes and how IoT is developed and how Arduino is work inside the IoT technology, right? So if you have any doubts, please post in the comment section. We'll just since we are running out of time, we'll just go with the case studies where my co-founder and also an research developing manager in IoT research labs, Bharadwaj, will take care of next case studies which we are going to be used. So Bharadwaj is also a mentor where we used to work together for past 3 years. He also mentored more than 3 to 4,000 students, and he has good connectivity in all the technologies. He's a very eligible guy. Bharadwaj, I hope you are here and you can start your session. Yeah.
Hi, Akshay. Yep. So
Please
I'll
start
just
your
share my
session.
screen. Hope it is visible now. Is my screen visible?
Yes.
Okay, great. So yeah, I don't want to waste the time. So keeping time in mind, I'll just go with the flow. So the case study which I want to take up here is inhaler, smart inhaler. So rather than going up with fantasy case studies or which I get from the net, rather than that, what I thought is I'll show the practical case studies which we have implemented and we have actually took it to many hackathons and showcased to many people. So the first one, which I liked among all, like the best one, not the best, but yeah, one among the best, is Inhalo, the smart inhaler. So the problem statement which we identified here is, doctors suggest the asthma patients for the, a smart inhaler. But the problem is that doctors don't know exactly how many times the asthma patient use this inhaler. So how frequently they are using it, or what is the dosage level they actually use. So these all things keeping in mind, again, but why this gap is there? Because doctors, if they don't know exact parameters of this, they actually can't cure the patient immediately. So they take time. Also, they get the data only from the patient saying that, okay, I have taken so and so dose or so and so medicine at so and so time or something like that. And patient accuracy, getting the data from patient, the accuracy may be very less, right? So what I feel is there should be a technology which is tracking asthma patients, with all the parameters which are related to cure them and give it to hand over them to doctor. So this is what the problem statement which we identified and come up with the solution of smart inhaler. Also, there are 43% of increase in asthma patients and getting affected by asthma, every, like, for past 4 years we have seen this increment, and that is like more like 50%, right? So it's like very high. And also 3 to 10% of women are also affected by asthma. So why it is danger for pregnant women? So whenever you have asthma, you have to use the inhalers, right? So whenever you take the dosage, 70% of the dosage level goes to your blood vessels and it cures you for your treatment, but remaining 30 will actually affect the baby in the woman even. So again, so there may be side effects, right? So this may harm the baby also. So higher dosage level, if they use in a higher level of medicine dosage, it will affect the baby also. So what exactly they have to use, how much they can use, and everything can be suggested by the doctor itself. So taking all these parameters, we consider to develop it. So the proper solution, as I was saying, we detect the dosage use, we also remind the patients to keep the inhaler with them, or to keep it available like that. We also detect how much frequent they are using it, like today in the morning or today in the afternoon or night. So 3 times a day or 2 times a day, we actually track them. Also, next step is like if they're using at once in the morning, so how many times they are using it actually. They're using continuously 3 puffs, like 3 times they're pressing and using the medicine, or just 2 times, or how they are using it. Like if they're using it, how many times they are using it, how many puffs they're considering. So we all calculate this. and also generating some reports, alerts, so that the caretakers or the nurse with them, or whoever will have the data with them to track the patients. Also, we provide chat box. We have provided chat box so that the patients can actually understand it, and predictive analytics, for the patient, and to better his health, and also the manufacturers. So what information we are giving to the manufacturers here is, for example, the bottle of medicine have 200 puffs for you. If you buy it, you get 200 puffs. So once 150 puffs are completed, so you have remained just with 50 puffs, and you need the other bottle for sure to keep it with you if you are continuing to use it. So we help manufacturers get their customers. We give them alerts saying that so and so client, so and so patient for you in so and so region has requirement of the medicine. So make sure you make it available for them. You call them, you sell it, or you keep it in the nearby medical store which they actually use it. So that the medicine availability for patients is also, getting solved with this solution. So it not only helps to track, but also makes, a connectivity between manufacturers, doctors, and patients, and also keep everyone connected and going in that way. So next comes technology. We didn't use any big technology here, building up all these things. It's like simple button press, a single sensor. Okay, so when you press the button, automatically the medicine, if you want to use the inhaler, you have to press the medicine on the top. I hope you have seen the inhalers, right? So on the top, we are keeping this button. So it's compulsory. If you have to, use the medicine, you press the bottle and automatically the button gets pressed. And our node MCU, which is part of like Arduino family kind. So it actually has capability to just get on, send the data to cloud, like ThinkSpeak Cloud or Firebase database or whatever we are using. So ThinkSpeak Cloud, actually we are sending the data and we are storing it there. So it'll send the data and it just goes to the sleep mode. Why the sleep mode? Again, to save the battery power. Okay, so that you no need to charge all the time. It will save the battery. So in the cloud, ThinkSpeak Cloud, it takes analytics and send it to MIT. We are just developing an app with MIT App Inventor. It's like not bigger task. It's just simple drag and drop and attaching blocks so that you can just simply develop an app. Using this, we have just pass the information from cloud to the mobile app so that we can show the analytics and everything there. And Firebase database we use for the credential storage and all the security part, whatever are there, like user ID, passwords, and all this is in encrypted format. All the data is for the higher security purpose. So we have used also IBM Watson chatbot. So it helps patients to give more accurate answers and quicker answers, and it's very parallelized way of structured, which I very like, which I liked a lot. So that's why we use the IBM Watson chatbot. So this is the technology, and the the workflow is whenever patient uses. I just try to put the laser. Yeah. So I think you can see the device is here. So whenever the patient uses it, it uploads the data to mobile or directly to the Wi-Fi. So we also give this Wi-Fi option where inhaler actually can it doesn't depend on any mobile phone again. If the mobile phone is switched off or not nearby, again there'll be a problem. So we are directly connecting to the Wi-Fi itself, where the patient can upload the data, and it also makes sure that all the data is available and sent to Wi-Fi. It has offline storage and everything. So once the data is coming to the cloud, we are sending it to different stakeholders like healthcare provider like doctors, nurse, and everything, their own caretakers like mother or husband or anyone like that. Then other people, even if they want to share, and also the support team. As I said, the manufacturer to make the medicine available or the count available. Also near the manufacturer, what is happening? So they're also getting analytics, like for R&D department and everywhere. They need a lot of analytics to be happening. So for example, in Telangana, how many asthma patients are there and how frequently they are getting used, used to this attack, or how many are increasing the count, or how many are getting actually cured. So all this data compared to Andhra Pradesh or compared to Maharashtra, like that. So we can generate heat maps even for different locations kind, and we can analyze. So also we can, So also we can analyze, saying, okay, in Maharashtra there are more patients, so let's create more of medicine there and more make availability of there, or open a store there. And which manufacturer doesn't like to have clients data, like they love it, right? So the data flow diagram is also very easy. The button just sends the data to Node MCU, and the processing unit sends it with the cloud, API call in the HTTP protocol to cloud, and we are using ThinkSpeed Cloud there, and they will check the credentials and everything, stores the data, all those things, and send it to the app which we have developed to have a visualization and alerts. So we have designed a go-to-market strategy, then financial projections, how we should actually do it. Then we have some uniquenesses in the system, like okay, it directly connect to Wi-Fi, or it doesn't have a longer battery backup. So it has a longer battery backup, and yeah, it also if there is no internet availability or something like that, we also provide message services once we get the data to cloud. So this can also happen. So I want to take another example also. This was one of the example which we developed. I'll ask Akshay in the end to cast his screen and also showcase the inhaler, how it looks and everything like that. So this is another example which we have developed actually. Sorry, I'm getting calls. Yeah. So this is another example. So this is an IoT, enabled vending machine, a Nimbu Pani vending machine, L2O. So this is the best product and the longer product which I worked on. So India's favorite drink is this Nimbu Pani. Like everyone likes, and in every season they want to drink it, right? So currently we have two ways to get this, Nimbu Pani. Roadside, where we have the vehicles there and we can go and get one drink. But we think so. I can say they use fresh at sometimes, but it's not hygienic. We have to compromise on hygienic. But also Coca-Cola and many other companies sell this bottles. It is hygienic, but it's not so fresh, right? Because we don't know whether it is fresh or not. So combining both hygienic and freshness, we have our vending machine. So it actually maintains the nimbus in cooler conditions. They actually take it at that time, cut them, and actually get the juice and everything in immediately. Also, we have given different options like sugar with sugar and masala combination, or salt combination, or many others like that. Also, we give hot water and cool water so that they can have lemon tea even if they want. So, and how it works and everything. So and this complete product and everything, we did not use any other big hardware. It was simply with Arduino Mega. So Arduino Mega connecting to few SMPS and power sources, and again connecting to few sensors, buttons, LCDs, and few motors. Yeah, the motors again are quality graded motors. Also, we make sure everywhere it's a food gradient wherever the food is touching to the machine. So yeah, so this is how the machine is built, and we have few projections and everywhere. And yeah, so I request now Akshay to just cast the screen, and yeah, you can show the inhaler once.
So this is the prototype inhaler we have built. This is the ESP8266 module, which is connected to a battery, where it is connected to a button sensor in the top. Yeah. So when we click the sensor, all the sprays, when we click the spray, the sensor will be switched on, and it will count it will be added to a count where we store that count to the cloud. So actually I forgot to tell you about the cloud part, where there are 2 or 3 developer cloud technologies, where Firebase is one of them, and ThinkSpeak, as Bharadwaj told you, that is one of them, and you can use Kaggle, all those things for real-time databases, right? So in IoT, every time we use a cloud, we use mostly a real-time database. IBM Watson is also a best example where you can develop data inside the cloud. So in this inhaler, one main point which I liked was this is it is a small battery, right? How much time it will take to discharge it? So we used a sleep and awake technology, where only when you switch on, presses the button or takes a puff, then only the module will be switched on. It will be in sleep, and it will process the data, and it will send it to using Wi-Fi, right? So only for 5 to 10 milliseconds, it will be switched on and keep on processing. Remaining time, it will be in sleep mode. So that is the main key feature which we built. Will which saves lots of power with small compact design. This works. So that is a single point which I appreciate and I want to add it. With this, I think we will conclude our presentation. If you have any doubts or queries, you can ask in the chat section.
Yeah, Akshay, Chirag Goyal has a question. So what he is asking is, I think Bharadwaj or either you can answer it.
Yeah.
Can you explain the process of IoT on cloud side? For example, I have Node MCU project which can toggle output with mobile via local network. What are the steps to achieve this via cloud?
Okay.
So if you can just give a hint to him or guide
Sure,
him,
sure,
I
sir.
think it would be helpful.
We can guide him. So, since you are having a Node MCU, I think it is can directly connect to a Wi-Fi, right? So you can just connect it to a Wi-Fi, and as I said, there are three different kinds of developing platforms: Firebase and ThinkSpeak and IBM Watson. You can connect it to any of those cloud technologies. After that, you can connect that to your mobile application. If you don't know how you can create a mobile application, I have a easy tool called MIT App Inventor. So if you go to Google and search MIT App Inventor, you will get a tool where you can just build your mobile application using drag and drop options, which is also a web tool. So you can just drag and drop all the options you have, like you can create logics using all the drag and tool technology. So yeah, that is how you can connect. If you want any more detailed information, or if you want us to support you, you can contact us anytime. So I think Bharatwaj wants to continue the presentation.
Yeah. So there's one more question. Just Rishabh Singh is asking, have you patented your project?
Which project are you talking about?
Yeah, inhaler. Yeah.
Right now it is in under process actually. So we are trying to patent it, and Bharatwaj is taking lead on that actually.
So inhaler is actually one of the product which is already available in the market. So we have tried for the patents, but yeah, that's not given up. Okay, and L2O Nimbu Pani vending machine is already patented on our name. We have the patents on the design part of the Nimbu Pani, the vending machine part. Okay, that's great. So I'll just introduce my company even, so that you people, if you have any doubts, you can also ask, contact us. So we also take sessions not only on IoT or mentor on IoT, we do also do on Amazon Alexa. There are, we take sessions on how Alexa is used with IoT and development of skill sets in Alexa. Then we also do 3D printing, where how a 3D printer is completely developed, or also how you can design, and if you have a 3D printer, how you get the output from that. And we also work on blockchain, connecting IoT with blockchain technology. So the data security is also a very big task. So once we get the information from the IoT devices, how to send it to blockchain, store it there, and how to retrieve it again. So coming again to IoT with artificial intelligence. So yeah, it again plays a major role. I don't want to take just artificial intelligence topic, because students often feel very bored just working with algorithms and everything. So what I thought is to make it interactive and more interesting. I have connected with it IoT. So whenever you start working with IoT hardware and artificial intelligence, it gives you very much interesting topics around, and to play around. So this is our contact. So we have Akshay contact mine as well. Also we have our Facebook page, Instagram page. You can just type AP Tech Village, and yeah, you can go to the platform. So that's all from my side. Any other doubts or anything? Yeah, so you can contact us anytime.
Thank you, Bharadwaj and Akshay. That was a very informative session, and especially for the guys who are like entering the industry. For them, this session would be an insight, and they would be very much interested to work further and also get details. So they'll definitely get in touch with you. I think you guys are doing a good job in bringing products which are useful to the society and also mentoring students and also professionals at the same time. We are lucky to have you, and definitely you added a lot of insights. And as IoT is a very good platform at the moment, and the boom in electronics actually. So, it is a very useful session, to be frank, and I hope the budding
Yep.
engineers
Thank you.
would be, budding engineers would be very much happy to learn these things. And thanks, Bharadwaj, Harshil. And so now we'll move on. We'll move on to the next session. So the next session would be from Kunal Gupta. So he is another enthusiast, hobbyist, to be frank. From his college days, he started working on several IoT related things, and then his hobby to create a lot of videos. There is a channel called YouTube Ghetto channel. So you can just Tech Byte, Ghetto Byte, right?
Yes, sir. I will
Yeah,
introduce
Ghetto Byte.
you, sir.
Yeah, he will introduce. So I have Kunal. So Kunal, you can just take the platform.
Okay. Thank you, sir. Thank you, sir, for welcoming me. Hi to all. Good morning. First of all, to all the participants who have come and have come for this. Let me just share my screen first. Yeah. So first, welcome you all and to the world to the Arduino. Now, to first starting with my introduction, I am Kunal Gupta. I am basically firmware engineer and IoT developer. So the thing on which I'm going to say today on this is about the microcontrollers and how to start with it. Like I'm just going to tell you that how literally everything on the world runs on a microcontroller. That when we say that the things run on bits 0 and 1, what do we actually mean by it? And what role does Arduino play in that way? Okay, so first thing which I would like I remember when I started with Arduino in my college days. So it was first very much like flashy and very interesting that we can control many things. Like earlier also many speakers have told you that what all things we can do. But then very first question which comes to my mind is that how actually our real-time products run. If you see around, there is automation all around. You take any industry, IoT, avionics, automation, industrial automation, smart cities, the automobile sector, everywhere you see kind of automation things or things happening from their own. So I got this idea that okay, all these things are being controlled by a controller, and then there are some extra sensors and also things. So I just used to think that what actually is the thing that actually makes them run, what is the system whole, what is the architecture of the system, how does actually things happen. So this is the question which I started hunting from my first day, not from my first day but after my first year. So slowly and slowly I get to know about the things that the first I get to know about the industries, different industries, automotive industry, automation industry, IoT industry, and what all things are common in all these industries. And that thing is our microcontrollers. Microcontrollers, microprocessors are used in every industry you say. So then I started, and then comes the Arduino. So Arduino is like, it provides a great platform with the AVR microcontrollers which it has. Okay, the Arduino has the provide all the like we can make all the actual industry projects on a table from the Arduino and its resources. So the thing which I got to understand that if to master, if to get into any industry, the basic niche which lies on all of them are the microcontrollers. As you can see, application of microcontrollers, like if you go to the automation sector, IoT sector, or automotive, all things works only on communication protocols. Like literally, like to be tell you in a better way, if I am talking to you, you are able to understand me because we have a common communication language between them. So does it actually happens in real time. Devices communicate, actual real time devices or all the products work because they are communicating via some protocols, via some zero ones or PWM signals and all such kind of things. So the basic thing from which Arduino I got the help is that I have like Arduino has provided all the kinds of libraries. You can take for Wi-Fi also, for GPS, for almost all of these libraries. So what I started doing is I started hunting these libraries. I started understanding these libraries, and once you get to know about these things now, you actually get to know that okay, how actually my world, the things are working in the inner level. So Arduino provides you the great amount of open source libraries, open source community for starting with these, for getting to know with these. But what I thought in the second year afterwards is that if we restrict ourselves to Arduino, we can't go on to the real time projects. Okay, because this Arduino is not used in real time products. It is used for beginners, for hobbies, and for starting out the things. So what I started doing and what I recommended all is that I take Arduino as my this the reference, and I started understanding things from this. Understanding things for what I mean that getting into the libraries, making my own libraries so as to know about how the things are working. So, and then I get to know about the embedded C programming. What exactly is embedded C programming? I will just get to know about that. Before that, I would like to go to the microcontrollers. Like in the previous one of the speaker has told you that the microcontrollers thing will also be discussed. So I'm just going to tell you its brief overview. So see, microcontroller is just like a normal brain. It is literally like a normal human brain. Just like we have a brain, there is a processor in it. The all things are happened by the brain. Same way in microcontroller, all things are being processed by processor. Now with processor, other things are attached, like with our body, our hands, our fingers, our legs, all these are attached. So you can consider them as your peripherals which interact with the outer world. Outer world here is your picking up a glass or anything for a body. Same way for microcontrollers, outer world is the sensors, is the environment, is the modules, and those modules interact with the processor. The main thing which processes all the things are these the extra peripherals which you can see over the figure. PWM, UART, USB, I2C, SPI, ARM Cortex M. The ARM Cortex M is not a peripheral, it's in a processor. So, so like there are many such peripherals which are attached to a microcontroller. So the basic thing which I get to know in my college days, that if I want to do things with the microcontroller, I don't have to make projects. I have to understand these things. I have to understand these ongoing inner protocols which are happening. Like you can just take it as a thing. If you like take it as a body, you will not be able to pick a glass or do the running if you don't know how to work, if you don't know how to use your legs, if you don't know how to do the things with your legs and body. So same way with the microcontrollers, if you don't know how their peripherals are working, how their protocols are working, how inner things are working, you will not be able to do things in a real time project. Okay, so like there are many these just a second. Yeah, there are many Arduino Avia microcontrollers which I have, like Avia 328 are the which Arduino and Arduino Nano has, Arduino Mega also at Mega 2560. So these are like the vast open source community platforms which are given on the internet with abundance of links and resources. So what I recommend to all the beginners, and I always to say to the all those who come to me for learning the embedded C, that you just don't concentrate on the project making. You just concentrate first on the learning and approach of the project which you make. A project can be made from a YouTube video by saying a 15 minutes video, but what approach you have applied for this video for a project, how many projects you have done, how you have learning you got from a simple project. Because like I just tell you, in my second year I have not done any good very good amount of project, like not good amount but any big amount of project. Like I have done normal LED blinking, UART communication and all such things. But the main thing due to which today I got like today because of which I get to know about embedded C is like I do the all the basic program projects only, but with the approach that no one has taken in my college till now. It is not with Arduino IDE library, but reading the core data sheet and understanding from its registers. Like I will just give you its view that what I mean by that. Like if you go to the data sheet, then you will see that this is the thing, the whole 435 pages of data sheet actually controls your whole Atomica 2560. Okay, and all the inner libraries which you see, so all those are happening from these. So now if you go to any peripheral and you go to its register description, and you will see that all the communication is literally handled by single bits and bytes. Like you can literally control, like this is the logic analyzer which is used for communicating. Okay, look, let me lead, I will show you that later. Okay, so this is the thing which I get to know from the second year of my college. Okay, just a second. Yeah, okay. So then the another thing which I would like to tell you is that once you start with the microcontrollers and the approach the way you approach for your learning, then I get to know about things like, okay, in real time the processors like ARM Cortex, STM32, and all such kind of real time modules and projects are used. So if you concentrate on the project by the approach by which you can learn maximum out of things in your college time, because in college time only we get the ample amount of time to learn out the things. Once you get your graduated from the college and you go to the real world, I don't think, as if my experience and as if I have talked with the people, we don't get much time to learn out the core things, because we become the task oriented or project oriented, because that's obvious. So in the college, if the approach and the learning should be, if you want to master microcontrollers or want to do with the embedded systems kind of thing, because embedded systems and these microcontroller embedded C, these literally form the niche of all of, not, I will not say niche, but they play an important role in many industries. Like you can, as I have told you the examples. Okay, let me just switch my window. Okay, so yeah, this is the thing. And now the other thing is that all these peripherals, electric circuits, are called controlled by peripheral registers. To give an understanding of this thing, I would like to tell you that you can take all the peripherals like SPI, UART, I2C. All these are like normal electronic circuits. Literally, because all these peripherals are being made on flip-flops and shift registers. If anybody have got an idea or would like to see on it, they can Google it later on. So all these are literally made on the core electronic circuits, like from transistors, resistors, and all such things. Now, what here comes the field of VLSI, VHDL. All these electronic circuits, miniaturization of these electronic circuits in a single size of your nail. This comes under the VLSI, VLSI, VHDL. So if you to get an overview, like I said you in the earlier, that I first get to know about the architecture. So first I get to know about, okay, what exactly microcontroller is, how it is built. That thing is handled by the field of VLSI, VHDL. Then comes the persons or the people who work on these microcontrollers to make the real-time projects, to make the real-time products. That thing is come in is done by the embedded firmware developers, embedded software developers, or hardware developers. And then comes the final application layer, which makes these modules, like in the embedded and the firmware, there are many phases and submodules in it. So this is the, so yeah, so the all the peripheral registers are being controlled by the electronic circuits, and those electronic circuits are controlled by the binary world. Literally by 0 and 1 we can enable any peripheral, we can enable or control anything if you get to inner details of these. Okay, now and then the next question comes is that how you develop your control, like to tell you more thing on this, like the microcontroller, like I said, it's in a processor. So it's in a processor which computes something.
Hello, Kunal. Hello. I think there's a power outage at Kunal's side, so I think he can continue taking it. So, Vikrant, can you take it by the time Kunal comes back, so he can continue later?
Yeah, sure. Definitely. So,
Yeah. So the Kunal session was very interesting, and it would have been very useful for the guys who are just starting. So he was giving more impetus on how to start and what to start with microcontrollers. So most probably once he comes back in the session, we'll take him post your presentation.
yeah, sure. Just give me 2 minutes.
Okay. I think he's back. Let us see if.
Yeah, so light goes off my area and the net goes. So sorry for this thing, and I'm just restarting. Like my laptop was also on battery. It is not. It is. So I have just on it now. So
Okay.
sorry for this disturbance, sir.
No problem, Kunal. You can continue. You can continue where you left off.
So like the PPT is not because it's on my laptop and I'm just owning it. Meanwhile, I will be telling you the things like this only. Okay, if got any issues?
No problem, Kunal. Continue.
Okay, so the thing which I am telling you is about the peripherals and the architecture on how to program your microcontrollers. See, the one thing I would like to first tell you is that when I do things now, I always get this. What is the purpose of this thing? Like, okay, I have told you the things about microcontrollers. I have told you the many people have previously told, and I have given you a good overview of all this platform. But first, we should know that the things which we are doing, what will be the final end thing which we will be able to do, what will be the final end things on which we will work upon and that we will be able to make. Okay, so because these things, if I tell you by my experience, these things are the those which motivate me to work more and more on the hardware side and on the firmware. So first, to understand that what exactly, how does exactly embedded systems comes in our real in our life, and what role does a microcontroller play. So what I started doing is I started reading books about embedded systems. Then I start getting to know about it all the industries. If you'd see, like I have told you this in the previous also. Okay, so all the microcontrollers are used. Then I started seeing the things like, okay, now if I want to get into a particular industry or in a particular product, what all skills should I know? Okay, so the basic skill which is common to all is the first is normal programming, normal firmware development on the microcontrollers, because communication and the UART SPA I2C protocols works on all the industries, almost on all the industries. These are the basic ones. Okay, then I get to know about things. Okay, now if I have done the things related to the some basic things, then let's get on to the advanced. In the advanced, like then I started on the IoT. So as many and traditional ways for ESP8266 and ESP32. But as my personal choice, I don't like ESP8266 because you can take it as a Chinese way because it's in a Chinese. But yeah, but I know that all the controllers come from China only. But what the main motive was not to work just on ESP8266, but to understand that how exactly my Wi-Fi thing, my HTTP thing, my all such things are working, so that I can work on other Wi-Fi modules also, not sticking to single modules. So though by those I just started in that way. The Arduino comes a very handy tool because Arduino has lots of its libraries, lots of its open source communities by which you can learn and understand these things. Okay, and then comes the things like I thought of making a YouTube channel, Get to Byte, a platform, because what I thought that in the college or in all the many webinars or the training sessions which are taken for the Arduino and IoT, things are told that what projects we can make with Arduino, what things we can make with ESP8266 and IoT. But real thing, the embedded C, the firmware development, that thing is not very much told as a college students to a college students. Okay, so I created a YouTube channel Get to Byte on which I upload videos totally on AVR microcontrollers, totally on embedded C only. So I have done a playlist on AVR microcontrollers also, and I have also recently started with STM32 bare metal coding. So if anybody interested, they can check out the channel. I will just post it in the comments, Get to Byte, and share its link also. And if any queries, if anybody wants to ask anything, they can ask in the comment section. And that's it from my side, sir.
Yeah. Thanks for sharing your experience, Kunal. I think the guys who are here shall follow the path you have shown. And I think for the beginners, especially, it is very useful where to start and how to proceed. Good that you have been doing very good things at a young age. Thanks for that session, Kunal. Have a nice day. So we'll next move to Vikrant. So Vikrant, can you just take it forward?
Yeah, sure. So,
Okay.
uh, yeah. Uh, is my screen visible?
I think it's just coming up, Vikrant. Give us few minutes. We are able to see you, but not your screen.
Oh, okay. So, now it's visible or it's not?
Not yet.
Now? It's visible?
No, no, Vikrant.
Okay.
We see a
Any
blank screen.
any
Yeah,
chance
continue.
you are using a different desktop, extended desktop?
No, no, no,
Okay.
not right now. So,
I think you can switch off your camera, Vikrant. Might be
yeah, yeah,
it's
definitely.
slow or something. I'm not sure.
Okay. So it's still not.
No.
Wait. Now presenting. It's still visible now.
Yeah, now it is okay. We are able to see your screen.
Yeah, yeah, that's perfect.
So, guys, just to give an introduction of Vikrant. So Vikrant is basically an IoT engineer again here. So he has worked on many open source related things. He does contribute to the community a lot through his speeches, and again he's another guy who mentors students a lot, and also he contributes to the community by posting lot of his firmware codes, and also he works on IoT related things. He has worked on several projects till now, taken several sessions in colleges. Another very enthusiastic engineer around India. So there is a lot to learn from him. Vikrant, we are looking forward for your speech. Thank you. Thanks
Yeah,
for joining.
Yeah, thank you, Shri, and good morning, everyone. It's sorry for the interruptions. Today's world, like when we don't have the offline meetings, so we the internet issues and other stuff comes into picture, and it kind of disturbs the platform. But never mind, we are just getting started, and it's great, guys. You came up in this holiday, and and it's a wonderful platform from where we all can learn. So today I would be more focusing on the impact of open source hardware. Most precisely, I would be covering what is open source hardware and what is IoT, what is open source hardware in the connected IoT world, and how the open source hardware has shaped itself, and what are the evolving softwares and hardware stuffs that will be coming in your future in open source. So let me talk about myself first. I'm actually an embedded engineer. I'm currently having a 4.5 years of experience in embedded software and hardware domain. I currently work as an R&D engineer in one of the automotive companies. I'm also a founder of a Deeply Embedded. It's a community which regularly runs open source sessions, tech talks from various experts and communities, and we also have uh, 600 plus folks members who are the part of the community, and it would be great if you all can be the part of it. If it's not, I will share you the link in the chat or the description later on. I'm also a tech speaker. I'm a trainer and I'm open source enthusiastic. I regularly share a lot of open source codes, and I regularly mentor students in colleges. Uh, and I'm also a trainer wherever it's like feasible for me to train some industry experts who want to learn embedded. I'm always there for them. So I'm being given a lot of tech talks related to different various topics in various communities like IoT NCR, Google Developer Community. I'm also a founder of my own community, Deeply Embedded, and it's great, guys, that I got an opportunity to speak at the Arduino Day. So uh, let's go on further to understand what is open source hardware. Till now, we have a lot of industry experts have covered up a lot of various topics, and they precisely talked about the architecture, how the microcontrollers work, what is IoT, how the IoT is reshaping various verticals and different domains. But today, as an Arduino Day, we need to really understand what is actually an Arduino. And if we talk about Arduino, we get to a picture called as open source hardware. Like now you see even the college students, not only the college students, even the uh, school students are exploring our Arduino. They are tinkering with Arduino. They are building a lot of projects with it. And due to its open source capability, innovative ideas comes into picture. So what exactly the open source hardware is all about? So open source hardware, if we talk about by the definition being given by the OSWAC, that's one of the biggest open source hardware organizations. It talks about is a hardware that is being publicly available so that anyone can study, modify, and distribute, and sell that hardware based upon the hardware design. So like suppose if I make an hardware, I make a hardware schematic for a design. I'm working on a project, and I want that people should learn from my design, and I post that design onto some my GitHub link or some forum where people can see, people can modify, people can give me ideas. So that is what is all about open source hardware. So how does this open source hardware really works in the picture where we have companies which were very keen not to share their hardware or schematics, and most of the companies mostly keep themselves isolated so that people should not get to know much about the hardware details. They only get to know about the software. So how does this really helps companies to really gain profits and make a picture in the market field? So first of all, when we share any open source hardware, like if I develop a hardware, if I share it in public forums, how it really helps me? It really helps you to collaborate with ideas. Like suppose I share the hardware, and there might be possibilities that that hardware needs the modifications and redistribution. Maybe there can be other folks as well who might look at my hardware and get some ideas and might collaborate with me, and we can be an awesome teams and communities. And that's how the things gets to start working. It's not like a one person who is working on a project. It's a team that have various professionals working on different stuff, and they get together and develop beautiful products. One of the key example, if you see, is the Linux Foundation. It's currently one of the most popular open source projects, one of the widely biggest project in the world. We all know the Linux distribution been operating at a massive scale, and it just started with this with the person who just shared one of his Git repositories, and once he shared it, everyone started to collaborate and started working on it, and that's how the Linux Foundation was established. But that's one of the questions that came to us in our mind about Internet of Things. We have a lot of hype about Internet of Things, and we see like due to evolution of Internet of Things, open source hardware has gained popularity, and many companies have come in front, and they have started working not only on the application side but on the firmware as well as on the hardware side. So it's very important to understand how this Internet of Things work for us. So we have one layer, if we understand Internet of Things through various forums and technical, we see a lot of insights. Like there are different kind of layers that works on. So I will be also talking about those layers in a very precise manner. Like how does this Internet of Things work? It's one is the device management platform. Device management platform is a platform where it's currently is a SoC or an MCU that is based, and it's taking the data, fetching the data from the sensors. And sensor is a device or electronic circuitry that is designed to analyze the physical change in the parameters. So there is one device management layer that operates to take the data from the sensors or devices, and there is one connectivity platform. Now you have taken the data from the sensors. Now you need to send the data somewhere so that you can generate some meaningful insights from that data. So how would you do that? How would you transfer the data from one device to another device, and that another device would be analyzing that data which is being collected from the one device? This is the connectivity platform that comes into picture. So connectivity platform is to transfer the data from one end to another end, and there are a lot of technologies that can be involved in it. For example, if you talk about low distance technology that needs low power technology that needs to transmit the data, that is, you can use BLE for that. For higher distances, you can go for LoRaWAN, your Wi-Fi. You also have 5G, 4G, but it entirely depends upon your project and what are the case scenarios that are involved in that project. So based upon that, you select the connectivity platform that you have established in order to send the data from one end to another end. And then there is an application enabled platform that is implementing data analytical tools to actually see how the data that is being collected by one device would be fruitful for our project. So this how the IoT architecture basically works. And if you talk about the hype of the IoT, obviously we all know IoT is an emerging market. But what does an analyst say about this IoT market? So one of the reports that been published by the RTC forecast really predicts that it's the market that reach around $1.2 billion till 2025. And till 2025, the IoT technologies will be 95% of electronic design. So the 95% of electronic products that will come into the market would obviously will have IoT enabled into it. So that's how the craze of the IoT is going and how the IoT is impacting day-to-day life. So let's see upon the various verticals that is there in the IoT sector. Obviously, earlier experts have already covered those scenarios and aspects, so I will not go into much detail, but I would just cover an overview. It's like, how does the IoT help this smart farming, smart retail sector, smart manufacturing, smart automotive, smart connected home devices and variables in B2B Connect. So the smartwatches that we wear today, it's based on the IoT application. You have the most of the smartwatches that we wear, it's based upon the BLE technology that communicates to the app via Bluetooth. The connected homes that we have, Alexas and Google Home, that connects to our loads, and it's able to control the loads uh, through voice applications. We have automotive devices, like suppose the car maintenance system that is there in the cars. It regularly communicates to the platform so that we can analyze the performance of a car and improvise the car performance based upon the data that's been collected. We have variables, we have aerospace and defense, where the IoT is creating a lot bigger impact. So these are the various verticals and sectors where the IoT is critically creating a strong impact. There's no sector in which the IoT is not taking into picture. And with the influence of the IoT, the device which is collecting the data from the sensor devices becomes at most important. That's why the capabilities to develop a quality firmware or a hardware, it's at most important, because there are a lot of key areas where you will put in your device. Maybe your device might be at some place that is isolated, and it's bearing harsh environments. There, the complexities to design that hardware, as well as the complexities to design the software, are clearly different from a normal hardware that you design, or a prototype that you design at the home. So those are the key aspects where the quality firmware and hardware comes into picture. So how does this open source hardware in the connected IoT world actually works in? So we discuss about the various verticals, we discuss about how IoT works, we also discuss about the various segments where the IoT is creating the impact. But how does it really works out? So let's see with an example where we have an input or a sensor. Sensor is nothing but electronic device which or electronic circuitry which analyzes a physical change in a parameter. Let's suppose the physical change might be a temperature. So a sensor detects a temperature, sends this signal to the controller. The controller is an MCU or an SoC based controller, or an FPGA that has been programmed to order to analyze the data being recorded by the sensor. And the sensor is sending the data, it's converting that data, the physical change, into electrical quantity, and that is being analyzed by the controller. And controller can be an MCU, FPGA, or a SoC based upon the specifications and the requirement. Then the data is being collected by the control center, it's being sent it to the like command center, what command you need to do. So suppose this is the architecture of a fire-based system. Like suppose when the temperature reaches above the threshold, the controller detects that temperature and sends the signal to the command center, where you need to actually turn the sprinkles on, so that the temperature which is being risen, the too high temperature which can be risen, which can be risen by the fire or heat, can be reduced. So these are the key areas where the IoT takes place into a picture. This is one of the examples how the sensors and actuators are working out to day-to-day life to impact the IoT world. So we have sensors here. We have the computing. That computing is any MCU, a microcontroller, or a processor, or a system on chip, or an FPGA. Based upon that, it's an output or an actuator, the command that that a processor needs to, the command that the output needs to happen. And this is a connectivity technologies where we, at one side, we might be doing some task by the computing unit, and another side, it's we are sending the data to the cloud-based platform in order to analyze and predict the happening and improvise the situations. So let's like more focus on how does this open source hardware has really come up into industry, and how it's been created. So there are two graphical pictures, we see open source software is being currently being used in 80% of the uh, industries. So indirectly or directly, it will be into the industry being used. But as compared to the hardware, see, the hardware has not been grown from that speed as compared to the software. But if you see, the hardware has over the last decade has been tremendously growing. And a lot of the companies like Arduino, Raspberry Pi, Adafruit, SparkFun, Seed Studio have come up and designed their own open source hardware to solve major challenges and to provide hardware to enthusiastic hobbyists so that they can really develop their own projects and working. So this one of the graph where how the hardware has taken place. This is the open source hardware community organization was being established in 1990. Then there was an evolution of companies like Arduino and Raspberry Pi, TinkerCAD, and architectures like RISC-V, which currently seems to be an architecture that can even come up in mobile phones and laptops in near future, and it's entirely open source. We also have one project that came up in the near 2006 2007, that was open computer project. That project used to control the devices through your human brain nerve sensors. So a sensor was kept at your human brain. It used to analyze the signals being 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 sent by your brain when is thinking, and based upon those signals it used to control the device. So this was one of the most uh, widely accepted open source projects in the industry. And there was another company named Minobroad which developed open source projects, open source hardware for various thinkers, even for the industrial folks as well. So this how the industry has established over the past few years. Earlier, the open source hardware used to be like area where companies used to not invest. Earlier in my college time as well, when I was in second or third year, I used to hear the words that if you want to be a good engineer, then you need to have a patent. And if I observe over the past few years that even if you don't have a patent, the patent significantly doesn't matter to that great extent. What you can contribute as an open source developer is much higher as compared to have a patent, because many companies have patents of technologies that can revolutionize the world in earlier 25 years ago, but they couldn't able to really use those patents just because they had a fear that if this is technology is being empowered or is being used, then there might be some company who might copy that idea. So that mindset of restricting yourself not to share your knowledge with the people let the companies to fail. Like suppose a case, take of a camera company. The camera company had a uh, 30-year long back. There was one company called as Kodiak. It has a 30-year long back idea of those electronic cameras that came back 20 years back, 20 years after. But what they did, they actually had that idea, they patented it, and they did nothing of that idea. And 20 years later, if you see the Kodak went for 25 years, 30 years later, they went for the bankruptcy. So they were having that vision and idea that can revolutionize the camera industry, but they couldn't able to implement just because they had their one mindset of thinking in their mind. What would happen if we try to uh, innovate this idea and some other company might copy it? Eventually, some another company came up with a better idea that was way different from that idea which Kodak had, and it just revolutionized the camera industry. What would have happened if they would have worked on it? They would have opened some parts, some portion of it, and started renovating and redeveloping. Obviously, when this would have happened, other people and other communities would have joined, and they would have collaborated a lot in the research as well as in the development of it. So that mindset that used to be having 20 years back, 25 years back, to just confront themselves, not to share anything, is now changing. Now companies are coming up with new innovative ideas to share their information onto internet, just not to have a fear that someone might copy it. It also had to it basically empowered that it will develop more of their product itself rather than being copied by some another company. And believe me, if your idea is unique and um, it's your idea is unique and it's simple, then obviously it will be copied. But till that time it will be copied, you will be at a stage where uh, you will be much ahead from other companies or tech giants. So these are the one of the companies that we have currently existing, like SparkFun, Adafruit, Arduino, Steed Audio Studio. So SparkFun is one of the electronics companies that deals with a lot of open source hardware. Adafruit is one of the companies that develops a lot of hardware. Recently, they have developed a hardware which is called as which operates on MicroPython. So we are also looking forward as Python on hardware nowadays. I covered that section in one of the earlier tech talks in one of the communities, Python on hardware. Now we already had Arduino. We are most popular with that. We have Steed Studio. Steed Studio is a company which has recently come up with very beautiful hardwares or gateways that can connect to the cloud, and it's entirely open source. Now, let's talk about one of the most hype development board that is there in the market. It's like most popular board being used by the by hobbyists, by people who want to develop their own prototypes. And how does what are the functionalities do it have? Although the earlier industry experts have already covered it, so I will not go into much depth details of it. So we have obviously we have two microcontrollers that is there. One is used for USB flashing, that takes the signal from your computer and flash your main controller, that is the AVR based controller. We can also flash it through ISP pins that is there. We have reset buttons so that we can reset it out. We have voltage regulator. Voltage regulator is there to give a proper voltage to your controller, and you with the help of voltage regulator, you can power it through an external source. You also have a reset pin, 3.3 volt, RFFI, and the architecture and the software that makes the Arduino more fruitful is like it's entirely open source. It's you don't really need to write your own codes. Many a times, if you are facing any difficulty, you can go to the website. You have a lot of links to study, and even if you don't have a knowledge of embedded C or C++, you can develop your own codes or projects. That's the beauty of this Arduino. So more key insight feature of its hardware is its M7 diode used for polarity protection. That is like suppose if you have a wrong polarity, let's you place ground to VCC and VCC to ground, still the controller will not get affected because it has a polarity protection in it, a diode that is there. It also had polyfuse, like suppose if you connect any device that tries to seek up more current from a controller it cannot provide, then obviously there is a chance that your controller might get damaged. So in order to protect that, there is a polyfuse which tries to protect your port from not getting damaged, because once you try to take soak up more current, like suppose let's understand from an example, like if you're a person who can uplifts 80 kgs, and if I put 100 kgs on you, then you won't be able to sustain yourself. Similarly goes with your controllers as well. So if you try to drive, if you put on a load that soaks up more current from your USB port, then there is a possibility that your USB port might get damaged. So there is a polyfuse that protects that your fuse from not getting damaged. It automatically shuts down your whole MCU once your device tries to take more current from your USB port, which it cannot deliver. So it's a two-layer PCB. It's external powered circuitry. All the circuitries that are there, it's entirely open source. and you can refer to the Arduino website to order to understand how the Arduino is being developed. So what are the free open source hardware, softwares, and free operating systems that you have? So operating system is it's like you are not coding at the base level. There's one programming that we have is like you are programming your microcontrollers through register level programming. I've also covered this in one of the sessions which I took. What is bare metal and application layer programming? It's available on my LinkedIn, and anyone who has any doubts can feel free to see that presentation. Most importantly, I would be more focusing on here on the two operating systems that we can use on the controllers, which can be used for the software development. So there is one free RTOS that is widely popular as well as in industry, and as a person who wants to develop a good amount of software that is able to control various peripherals on devices. And there is one operating system that is regularly being coming into market, that is RT Thread. There's, if you talk about the hardware, then we have hardware softwares like KiCad that is open source, and it's I wouldn't say it's powerful like Altium, but to be very honest, KiCad is one of the open source softwares which is quite powerful and can be used to design at least 2 to 3 layers of PCB very easily. So these are the various softwares and layers which you can really work on. And if anyone feels like to go into much deeper insights of it, then they can feel free to reach out to me anytime for any more discussions, because these are the topics which obviously requires 1 to 2 hour more time to explain. So thank you.
Okay.
So anyone has any doubts, they can reach out to me through chat window and through comment sections.
Okay. So while they post a question to you, Vikrant, I think Kunal has a question from Satyam Kumar. So what he is asking is, what should be the thought process to solve problems, that is while writing programs? So Kunal,
Okay.
the question was to you.
Hmm.
Or Vikrant, anyone can take it up, no problem.
Okay, so what is a thought process that you should keep in mind while you are developing software? So when you talk about softwares that you develop it at a little professional level, so one must need to show that your software that you are developing should be clean enough to be understandable by others. Number one. Number two is it depends upon your application. What application for which you are writing the firmware. You need to analyze whether if your application is big enough, then you might need an operating OS, or if your application is small enough. Like suppose I take two case scenarios here. One case scenario is to control your motor while reading some sensors input. So here you don't have that very strong application where you can go and run your operating system onto your MCU or your SoC based controllers. You can simply program it taking your pins as input and controlling your motor as an output, and you can control and drive your motor. But when you have a bigger application, let's suppose you have 3 devices that are communicating on the different ports, different protocols like RS485 UART or SPI, and you need to drive those data, and you need to also fetch the data from the sensors, upload it on a cloud-based platform, control your devices through output like motors, actuators. Then this application is a little bit complex. You might need to run an operating system like FreeRTOS or any other operating system that might be there in order to write a feasible firmware. Or if you're developing by yourself entirely bare metal, then you might be able to develop it, but it will take more time that might not be required to give to that project. So it entirely depends, number one, on your application. Number two, uh, what I said is when you are writing firmwares, make sure that it is, uh, it it's scalable, it's feasible. It should be like if I need to add new features into it, I can readily add new features without disturbing the previous development. Number three, it should be well designed with less complexities. It should not have too much complexities inbuilt. All the functions that you are developing should accommodate very less amount of memory, and the complexity should be in a way that reduces memory constraints on a controller as well as run feasibly without consuming less power. So these are the three verticals where you need to focus, and this comes not with only with just developing in a day or 1 week or 1 month. It comes with years when you start working on writing quality firmwares. Hello? Hello?
Yeah, hope that answered your question, Satcham. See, yeah, he says thank you. Okay, so thanks for answering that, Vikrant. Vikrant, as I mentioned, he's another approachable guy where you can contact him anytime over his LinkedIn profile or through his direct contact and ask your questions, post your questions, get information. So these are all guys who have worked in the industry, know in and out, interacted with number of students. They know how to teach the students and mentor them. So a very good session, Vikrant. Thanks for taking that session. So guys, I think we are too much loaded with the data. So we have planned a small quiz kind of game. Sure, we'll share the mail ID. Someone has posted to share the mail ID. Definitely post this. You'll all receive your participation certificates and all through us, along with all the contacts and sponsor related data. So we'll just try to play a small game here, which is called Kahoot. I'm not sure how many of you played it before. So we are going to provide goodies through this. So what you have to do is, guys, just go to your, open your mobiles, or you can install a app called Kahoot. So I'm just typing it here. You can see in the chat window, Kahoot or kahoot.it on your browser. So either install Kahoot app or Kahoot IT in your browser and be ready. So I'm sharing my screen, guys. So once you open it, you will see it will ask for a pin. So you can see the pin number here. This is the pin number. So once you enter that pin number, your name will appear in the screen, and then we'll start the quiz. So we have around 10 minutes time. Either try to install the mobile application Kahoot, or you can use kahoot.it in your browser. So I suggest you, yeah, we have a participant already, Pratima Kadari. Very good. Yeah, we have 2 participants here. So take your time, no worries. We'll wait for everyone to join. So Kahoot is one small platform, guys. You can use it with your kids at home with your family. You can play with your family, post questions. It's a very interesting platform. So it is used very widely these days. If you are interacting with students, some of you might be interacting with students, mentoring students, school students. So you can quiz, you can conduct quiz using this platform. And during this virtual scenarios where we are having this COVID kind of thing, people are reliant on these kind of apps. So if you have any problems joining Kahoot, please post a message. We can help you out. Akshay from AB Tech Valley, he is using this intensively, so he can help you out. We all here mentors can help you out. We have Pawan Shinde, Mitesh, Abhilash, Vaibhav Basin, Sonam, TC, Danesh, PP, Sinturakannan, Archana, Nirmal Kumar, Chirag, and Arduino Love. I'm not sure. Uh, good name. And finally, Pratima Kumari. So we have around 14 members. So guys, just to keep you engaged, anyway, we'll be announcing it again. Whoever are participating here in this event would be provided certificates. So we may not be able to provide hard copies due to this COVID scenario, as this is a online session. So we'll be providing you a soft copy of the certificate. So definitely, if you guys, one among you, if you are like searching for jobs or something, definitely there's one which you can add as a add-on additional activities which you did. Definitely it will be useful. And as the speakers mentioned, whether it be Akshay from AB Tech Valley or Vikrant or Sanjeev or Kunal, so these guys they have very good experience in mentoring you people, so you can reach out to them any point of time. And specifically in your domain, if you have any requirements for the guys to be mentored or any college related seminars need to be taken care, where guest lecturers need to be invited, so you can definitely reach out to these people. These guys can give speech not only on these Arduino related things, mostly on embedded related boards. So putting a stop to that, I think we have enough people here. So anyone joining, just can someone post a, is anyone still trying to join, or we can continue? Just post a message here so that we'll get to know that you are joining. I think we have 15 people here, and we have most of the people who has joined. So I think we can go ahead. So I think one person dropped. We'll wait for him to join, him or her to join.
Tarnigar, if you are thinking about Arduino, that was my mobile phone, so don't worry.
Okay, okay, no problem.
I just want to make it fun. That's it.
Okay, okay, okay. So I think we should start.
We should start, yes.
Yeah, yes. Okay. So let's start. So guys, what you have to do is Just to give a brief of this, once I say start, there will be a question that will be appearing on your screen along with options. So you just need to click the correct answer. Who clicks first will get the maximum points. For example, the person who clicks the correct answer first will get 1000 example, and then the next person will get 900 and then 800 and so on. And the score will get calculated. At the end of the game, you will have a podium finish. So let's start. Guys, keep your internet ready proper so that you will have the questions coming up properly. Okay. Pawan Shinde is back. Let's start, guys. So for the convenience of Pawan Shinde, I'll explain again. So Pawan Shinde, you have to answer the questions that appear. So who answers first will get maximum points. Start. Here is the first question. Which of the official Arduino boards have dual core MPU? So this was mentioned by Sanjeev in his presentation. Which of the official Arduino boards have dual core MPU? I think time is done. Okay, only 3 people answered. So there will be a time limit, guys. So you have to be quick and you have to be accurate as well. So Potenta H7. Only 3 people gave the correct answer. Let us see who gave it. Oh, Nirmal Kumar answered it correctly, and then Archana and Pratima Kadari. Okay, let us move to the next question. True or false? Arduino boards can be programmed using MicroPython. Is it true or false? Be quick, guys. Yeah, true, exactly. They can be programmed. So who is leading now? And Nirmal Kumar is still leading. Archana is second. Chirag is third. Okay, next question. We can generate PWM from Arduino using analog write-off function. Is it true or false? Using analog write-off function, we can generate PWM. PWM is pulse width modulation, which again Sanjeev sir has explained. Yeah, true, exactly. You can generate. So, and who has answered it? Nirmal Kumar, and achievement. Sonam is the highest climber, up 3 places. Very good, Sonam. But still Nirmal Kumar is leading. Next question. True or false again? Arduino IDE doesn't have a serial plotter inbuilt. Arduino IDE doesn't have a serial plotter inbuilt. So this was again explained by Sanjeev. Arduino IDE doesn't have a serial plotter inbuilt. False, exactly. It has a serial plotter inbuilt. And who has given it? Still Nirmal Kumar is leading. Good job, Nirmal Kumar. And 5 players have reached answer streak of 3. Very good. Okay, next question. How many microcontrollers Arduino boards has? How many microcontrollers does Arduino board have? How many? Yeah, 2 exactly. This was also mentioned by Sanjeev. And there are 2 actually. And Nirmal Kumar is still leading, and Sonam has climbed to 2nd place. Very good, Sonam. And 3rd, Archana, Pawan Shinde, Abhilash. And 3 players have reached answer streak of 4. Good job. So 4 answers in a row by 3 players. Very good. Next question. What programming language is supported by Adafruit board? There could be many answers, but related to this, yeah, MicroPython, yes. How many of them? And Abhilash, very good. Abhilash has 5 correct answers in a row. Good job, Abhilash. And still Nirmal Kumar is leading. Okay, next question. True or false? We can port operating system to Arduino UNO. Is it true or false? We can port operating system to Arduino UNO. Is it true or false? Yeah, false, not true. So it doesn't support an operating system, guys. So false. Okay. And Nirmal Kumar is still leading. Very good. Pratima Kadari, 3 correct answers in a row. Good job. Next question. Arduino boards have ICSP option.
हाँ
So Arduino boards have
बाद में
ICSP
करा
option.
लूंगा
True or
बाद में करा
false?
लूंगा
Yeah, true. Exactly. ICSP is for programming, and it's true. Who has given it?
हाँ करा लो
Nirmal Kumar. Very good. And Pratima Kadari has 4 correct answers in a row. And Nirmal Kumar is just not leaving the platform at all. He's just gluing onto that first place. Yes.
हाँ
Arduino
ठीक है
website has interactive schematic and PCB layout option where you can view location of every
अब
component.
तो कर
So
लो
this was, I think, Vikrant, you have to mute. Arduino website has interactive schematic and PCB layout option. Yes, true, exactly. Sanjeev has explained it. And who has given the correct answer? Still Nirmal Kumar, and Pratima Kadari has 5 correct answers in a row. Good job. Next question. Microcontrollers can have inbuilt EPROMs. Is it true or false? Microcontrollers can have. Yeah, true, exactly. Everyone answered. Very good. And Mitesh is making a comeback with 3 in a row. Good job, Mitesh. And Nirmal Kumar is still leading. Okay, next question. To read analog data, internal ADC in microcontroller is must. Read the question properly. To read analog data, internal ADC in microcontroller is must. Exactly, false, because see, if you don't have internal ADC, keep an external ADC. Okay, so 2 people guessed it right. Let us see who did it. Dhanesh has 4 correct answers in a row. None of the guys in the top answered it. Okay, so some microcontrollers doesn't have a ADC, guys. So example, if you take the case of a Raspberry Pi board, there is no analog interface. You have to use external ADC there. Okay, Bluetooth is a wireless communication. Is it true or false? Bluetooth is a wireless communication. Yeah, true. Very good. It's an easy one. Who answered it? Dhanesh has 5 correct answers. Good job. But still, Nirmal Kumar is leading. Next question. GPIO is a serial protocol interface in microcontrollers. Is it true or false? GPIO is a serial protocol interface in microcontrollers. True or false? False, exactly. It's not it's just a digital pin. It's not a serial protocol. Who answered it? TC has highest answer streak of 6. Very good job. And Mitesh has jumped to 3rd place from nowhere, but still Nirmal Kumar is leading. Good job. Next question. LoRaWAN is a wireless option. Is it true or false? So it's true, exactly. LoRaWAN is a wireless interface, correct. And who answered it fast? Again, Nirmal Kumar is making a comeback. 3 in a row. Good job, Nirmal Kumar. You are leading. Very good. Next question. Digital output is required for DC motor. To control a DC motor, is digital output required from microcontroller or not? Definitely, digital output will be from a microcontroller. True or false? It's true. Digital output is required, whether it be any form. Okay. So who answered it correct? TC has 8 correct answers in a row. Good job, TC. But Nirmal Kumar is still leading. Next question. Dip switch is a passive device. Is it true or false? Dip switch is a passive device. Is it true or false? It's true. It's a passive device. It's not an active device. Okay, and TC has highest answer streak of 9. Good job. TC is in top 5 from nowhere. Very good. And Nirmal Kumar is still leading. Next question. TinkerCAD is a serial interface. So Sanjeev has talked about TinkerCAD, right? TinkerCAD is a serial interface. Is it true? False. TinkerCAD is not a serial. It's a platform actually to test your code. So he explained about the boards which can be tested virtually, right? So false. Who answered it? Top 2 answered it. So Nirmal Kumar is racing ahead again. Okay, next question. Last 3 questions. 1.8.13 is the latest Arduino IDE version. True or false? True, exactly. This was explained by Sanjeev. Yes. And 4 players have reached answer streak of 3. Pawan Shinde is into top 5. Nirmal is leading still. Next question. Arduino doesn't have a library support. Is it true or false? Arduino doesn't have a library support. False, correct. You're right. It has a huge library support, which was explained again in the presentations. So 4 players have reached answer streak of 4. Pawan Shinde is into 4th place. Very good. And Mitesh is into 5th. Nirmal is still leading. And last question for this session. Arduino IDE has a complex interface. True or false? False, exactly. Sanjeev explained, right? There are only few drop downs. It's a very simple interface. And who answered it? So let us see the podium. Archana is in 3rd place on the podium. And Chirag is in 2nd place. And the winner of today's Kahoot is Nirmal Kumar. Very good. Congratulations, Nirmal Kumar. You got 17 correct answers out of 5. And 4th is Mitesh. 5th is Vaibhav. Good job. Okay, thanks guys. Hope you enjoyed this. Let us move back again to our sessions. So if okay, I think Sanjeev lost his contact. We wanted to just take up one hardware session, a hands-on session. So good one. Yeah. So hardware session. I think Sanjeev has lost his contact, so we might not be able to take at the moment. But thanks for participating, guys. It was. We hope you liked our session. So Sanjeev, 1 minute. Sanjeev, are you in?
Hello.
Yeah, Sanjeev, are you in? Hello.
Hello.
Yeah, Sanjeev, you are in.
Hello.
Sanjeev, we are able to hear you.
Okay. Sorry, just some technical glitches from my
Okay.
end. Okay,
So
great.
you want to take it forward, right?
Yeah, Joe. So is it okay? Like, shall we go ahead with the demo?
Yeah, yes, please. So that will just give a view of how to work on the board, so that people also just get to know. If
Right.
someone are just starting with Arduino, it would help them. So guys, Sanjeev is just going to give a view of the Arduino IDE and then how to port it and see the output from Arduino board with a simple example of the ambient sensor which he mentioned previously. And then if time permits, he will take through the TinkerCAD thing. Over to you, Sanjeev.
Okay. So just a moment. Okay, guys. So okay, so Dharani, actually the way I planned, right? So I thought of having the TinkerCAD session first, because that shows the how you can connect and simulate. But okay, as you said, it's better to start with the Arduino IDE, because we might be having interest of time. So we'll start that first, and if audience is still interested, we can go ahead with the TinkerCAD.
Okay. Okay, Sanjay,
Okay, let me
please.
share my screen. So you can see my screen.
We are able to see your screen. Yes.
Okay, great. So I just opened the Arduino IDE now, just for your interest, right? So I have just made a couple of more slides here. So I have a Arduino Maker 1000 board with me. So it's a Wi-Fi. It's a small board with Wi-Fi, so you can connect to the Wi-Fi as well. But right now I'm not going to do that. What I did is I connected a sensor, right? We talked about the other speakers in the morning, the previous sessions, they talked about sensor and IoT stuff, right? So I just wanted to demonstrate how quickly we can, start connect a sensor to the Arduino board, any Arduino board, and then, build up a quick code and download it and just start running it. And later, as you understood, like Akshay shared a great detail about how to start, how to begin with, and then how to go into depth, right? So Akshay talked about the bottom up approach, basically. So you get to know about everything inside, how it is working, even the device drivers, etc., how it is working, and then you slowly go into building applications, and then you that way you can be more expert. Another approach is top down. So you just start building some application without knowing even what is happening inside, and then go into depth, right? So I'm just doing the second stuff. So what I took is a VML 7700 sensor. This is an ambient light sensor. It looks like this, but it's a very tiny package, and it has an I2C interface. So if you are already aware about the I2C interface, right? It's two signals. One is clock and another one is data. You need two pull-up resistors on both the signals, and little bit of some kind of filter components are added for the power supply for this chip. So the chip needs around 3.3 volt supply. So you can give any supply, the supply with the voltage ranging from 2.5 to 3.6. It can tolerate any of these voltages in between, and it will work as specified in the datasheet. So taking Akshay's approach, right, you need to go into the datasheet of this chip. So you can search with BML 7700, and you can see that these pins are, how these pins are. So pin number 1 is SCL, as it is mentioned here. It's a clock signal. Pin number 4 is the SDA. And pin number 2 and 3, these are basically the the voltage and the ground. Okay, so this is the VCC, this is the VCC, and this is the ground. So you can take a look at the datasheet of this, and you will get an idea about um, the device. So this device basically senses the ambient light, and it gets the value in terms of lux. It has some conversion formulas also given in the data sheet. You can take a look at it if you're interested. Then the connection part. So I have this device on my desk here, connected to the PC, and I'm going to just hook it up as it is shown here. So just allow a moment. Okay, So I'm connecting the clock signal first. Okay, the ground.
Sanjeev, you wanted to show your video or just the screen?
Yeah, I don't have a camera. It's a good camera here. So maybe
Okay.
next time, we can, but it's the connection as it is shown here, right? So I'm just doing the same connections here.
No problem, no problem. Okay. So guys, just to give, so that you can visualize, you can just see whatever the connections he made in this picture. He's just trying to connect on his board, and he will show you the output of this particular board.
Yeah. Just a moment. I'm just doing the connection, just checking that nothing is going wrong. Okay, so maybe it's done. Let's see. Okay, so I made the connections. And so in the interest of time, I have a code. So what it does basically, if you see, like if you go to the Arduino IDE and go to the example, you will find the libraries, right? I think Vikrant was talking about, and even the earlier speakers, Kunal also talked about it. So the Arduino has a great deal of libraries which you can readily use, and you don't have to redevelop certain stuff. So the Adafruit, again, they develop a lot of open source hardware, right? And they have built this, they have given a code for the VML7700. So the advantage is if you use the code, right, you can connect, you don't have to write a software to work with the I2C interface, right? So this I2C interface is a standard stuff, and why to spend time in that, right? Already somebody has developed a proven code, just use the code and you are able to communicate to this device. Again, this device will be having a set of registers, and addresses for those registers will be specified in the datasheets. If you need to develop your own code, you need to go through all that, as Akshay mentioned, and you need to develop it from the scratch. You can do that. But if you are really interested in developing the application around it, right, it's a little on the higher level, then you don't have to, do this I2C interface yourself. So maybe you can make use of this code. It already communicates to this VML, sensor, and just you need to include this library. As you could see, right, this library is included. And once you include this library, it will automatically take care of communicating the device and getting the, the values of the, so this is the library, how you're using it. So VML is a library, and then read lux is a function you are using from that. So you're reading the lux data, you are reading the white light data, how much amount of white light is there or white noise is there, and then again the raw ALS data. So these are the three data it prints, and it prints over the serial port. So as I mentioned to you before, the serial is again a built-in library in Arduino. So I don't have to write a code for communicating over the UART. I can straight away use this interface. Okay. Next part is you can see that it's a Arduino Maker 1000 board. Now there is a board manager basically where you need to go get, and if that board is not installed, you can install it here, and from here you will get the board. And so for me it is already done, so I'm just it is done. The board is again connected to port 5, so it is showing that it's connected to COM5. So COM port 5. So but if it is some other port for you, we need to set it right. So quickly you can press and it shows the board info. It's a Arduino Maker 1000 and some ID, some serial number, stuff like that. Okay, so now we are ready to download this program. So this is a compile button. If you just want to compile your code and first time you are doing it, if you have already compiled it, in my case, for example, I'll just upload it. So that time also it will compile once more and then upload. Okay, so it's compiling, it says it compiles and it takes a little bit time. So in the meantime, I can show the another nice from where, as I told, right. So if you go to file and examples, all these examples are here. So different sort of sensors, and if you want to use a different boards, you can find those here. The digital input output related functions here, analog input output related functions here. If you want the serial communication and stuff like that, you can get those here. Okay, so like that you have even the display stuff and some other sensors. You can install also some of the devices which are not shown here. Maybe those are available in the library. For example, the different Adafruit devices, like this is a temperature humidity sensor, and I have already installed that library. Then there is a touch screen for that library is installed. There are some other sensors for which the libraries are installed. So once you install the library, it's very simple. You can use those code, right? And that will be a good starting point. Now, if you want to know from where to implement those libraries, so you need to go to Tools and then Manage Library section, right? Okay. So looks like it has done a CPU reset. Okay, so it has installed it. It has downloaded it, and so let me see if I am reading the data. Okay, so as you could see, it's kind of giving some sensor found, and it is talking about some gains and integration time, date and time, right? So it's okay. I need to change this to the required baud rate. See here in my code, I have used 9600 is the baud rate. So this is the speed with which it is expecting the serial data. So I need to set that accordingly, right? Okay, maybe I have set too much of delay here, and because of which it is not, yeah, it's too much of delay, right? So let me make it very small so that you can see. So I was really building a project because of which I made it very slow, because I don't need this data so often, right? So let me save it, and once more time I need to compile and upload. Okay, in the meantime, you can see in the tools, you have the serial monitor, you have serial plotter tool, right? There is another way you can code is through the Arduino block. And but this Arduino block I would recommend for the very beginners, so who doesn't know even the coding, like for example the school students. But this language is not very hard to pick up. Okay, so now see it's kind of reading the data, and it's logging the data, right? So this is the this is as it is printed here on serial. It's reading the lux value, the white light value, and the total amount of lux. So it's logging here. You can also use the serial plotter tool. It will just plot some those values here, and you can see the graph if you're interested. It's very readily available. Now another tool is there, which is the PLX DAC tool. So this PLX DAC tool is from a company called Parallax. So if you search on the net, you will find it. DAC is for data acquisition, and this is a very nice tool because it kind of captures the data over on the Excel file. But for that, you need to do a little modification in the code, right? So it's a little bit of modification in the code is needed, and so it's kind of let me check if this will work. So if you are more interested, you can read about it, and you can find the stuffs in the website. So this is a macro developed on the Excel file, and it kind of captures the data from the serial port and just plots it here. So it's not only for Arduino, any device, any microcontroller device that communicates over the serial port, it can do that data logging. Okay, now let me see if the same works here. Okay, it says code at comp5 is not available. It might be because this guy is holding it. And see, I just connected this from this tool, right? And it started logging the data, right, in the Excel sheet. So basically, when you develop your application, you can have the Arduino connected to the serial port, and you can get the data in an Excel, and then you can do several the plotting in the Excel, use the Excel functions and do the plotting and stuff like that, right? So it's very simple. You don't have to do anything. Maybe the same code also, basically I did not modify much. I just changed the serial the initialization of the serial port to baud rate 9600 from 115 to 00 given in the example code. This is just because this particular acquisition tool, right, it doesn't support that high acquisition, right? So that's why I have kind of, so in fact I can choose any of this in between, which is also supported by the this tool here, this device here. So with an example, this was just the intention of showing here is to how quickly you can get an example code and maybe modify one or two lines here. So I did not need this interrupts and stuff like that. So I just disabled that portion of the code, and I just made some little adjustment in the code, like this was the original code here commented out, and did a little adjustments here, just did so that it is acceptable by this Excel sheet, this particular tool, and I was able to log the data in the Excel instead of the serial monitor and the serial plotter. Right. So it took just 5 minutes basically for me to make the changes. But yes, definitely for initial understanding, you have to spend maybe a couple of hours, but that should be enough. Okay. So yeah, so that's all I had to show. In case we are okay with timing, I can quickly show the TinkerCAD. or you can also, you know, explore it by yourself. It's very easy. So it's fine. So Dharani, it depends on the interest of the audience, I believe.
I think it's almost 4 hour session, Sanjeev.
Yeah. So correct. It's a
Yeah,
long
so
session.
we can have it. See, as we have the guys who have been patient and listening to this, I think most of them would be interested to have sessions in future as well. So I think we should take it in the next sessions that we are going to conduct. So I think as you see on the screen, you can take up the number as well as the mail ID. So you can contact Sanjeev at any time.
Yeah.
And
You can
thanks,
contact
guys.
me on this.
Yes. So thanks for joining the session. And so I would again like to thank all the sponsors here, whether it be ULaunch or Skill My Subject, AB TechVille, Talentive, Deeply Embedded, and then Way to Know YouTube channel and Robotics. So these guys have worked hard to come up with the presentations, put the sequence in place, and help you guys get information what is needed today. Eh, all in all, we hope we were able to provide some information, useful information on this Arduino Day, and contribute a little to this open source hardware, which has been revolutionizing the world today, and helping many students get hands-on during high school level itself. A small attempt from us to just show that we love Arduino a lot, and also to help people get knowledge on Arduino. If you have any questions, comments, please write to us. You by this time know our contacts, who we are, and thanks for joining, guys. If you are looking for any sessions, please just write to us. We will get back to you. Akshay, AB Tech will take a lot of sessions through his company. And Skill My Subject is one platform where you can look through and get some information on BTech related things, and also some trainings that they conduct. Talentive is one platform where we post all open things. While we are not conducting, there are a lot of quizzes and all you can take on hardware, software related things, and there are some trainings as well. Way to Know is one YouTube channel where I particularly run it, and you have some content on technical, and there is embedded workshop series from part 1 to 65, where if you want to learn embedded, you can just run through it. ULaunch and Robotics are some startups, so you can just go through their websites for this. And Deeply Embedded, as Vikrant mentioned, is a community started and owned by him. So these people work a lot in the background to come up with the things. So guys, please post your comments, suggestions, and if you need anything in future, please reach out to us. Thanks for joining, friends.
Dharnegar, I also want to add something.
Sure.
So yeah, actually we did presentation parts and all everything fine, but Dharni sir was very actively participating and actively contacting every one of us and gathering us together. So he has done all the work behind the screen. So I think we need to appreciate him for the all the work, and I want to acknowledge his work as well for this event to be happening right now. So
Yeah, thank you. Yeah.
That's what I wanted. And one more thing is like tomorrow and after tomorrow is a Holi. So have a great Holi and have a blast. Take precautions and have a safe Holi. Thank you.
Sure. So what we will do is we will try to share all those links with you guys. So Akshay will be in touch with you. So someone has asked for the link of embedded channel. It's Way to Know. So Pratima has thanked all the speakers and the host for organizing. Thank you, Pratima. So the sponsors which you see, I think most of you registered through either Talentive forum or AB TechVille forum. So there we have mentioned all the logos and sponsors. So we'll also post this entire video for you online, so you can refer, you can share with your friends, and get back with your questions. So if you don't have any questions, I think we are done with the session. Thanks, guys. Any questions from your side? Yeah, Danesh says, thanks for giving this session. It's good experience for me. Thank you, Danesh. The whole intention of this is just to pass on our experience and help others. Thanks for attending the session. I think we are done with, we are moving towards the end of the session, and one more comment from Vaibhav Bashin. Really informative event. Thank you. Thank you, Vaibhav. Thanks for the nice comments. And Kahoot quiz was good fun. Sanjeevan, very good. Yeah, hope you liked it. So Sanjeevan, you can continue using it, Kahoot quiz, with your friends, with your family members. So most of the people worldwide use it. And Danesh asks for YouTube channel link. I'll be providing Danesh. Could you arrange it? So could you please arrange it? What are you asking? Please, Sanjeevan, could you please arrange it? Yeah, we can see in future with these contacts. I think we can arrange only a quiz. That's not a problem. So I have just provided the link, Danesh. Sanjeevan, definitely we will arrange Kahoot quiz in future. I think that's the most interesting one which people will carry from this session. So guys, thanks. Time to wrap up now. Please post your questions to us. We will take it up and we'll come back. Thanks for joining. Thank you. Thank you. You can leave the session.
Thank you all.
Thank you, Sanjeev. Thank you, Sanjeev. Thanks for taking pain and making this.
Thanks.
Yeah, thanks, Akshay.
Yeah, thank you.
Thank you, Dharani, for this opportunity. Thank you, Sanjeev sir.
Thank you. And we have other guys who missed out. We virtually thank them again. Yeah. Thank you.
Thanks all of you. Enjoy. Yeah, enjoy weekend and Holi. Yep.
Yeah.
But with safety. Yep. Okay.
Yeah. Okay.
Exactly. Okay. See you guys.
Thank you.
Thank you.
See you guys. Bye. Thank you. Bye.